everybody, if you haven't got a badge, if you could come down and get your badge. If you haven't got a badge, come get a badge. And don't do it. And we're going to have pretty much a full house today. And there are some seats down here. We should have, if we counted right, 2 seats left over. So you're going to have to get close if everything goes well. So come on down, grab a seat, get your badge, and we'll get started here in just a couple of minutes. There'll be some coffee and pastries outside. That's for us. Everybody grab a, cup of coffee, whatever, and we'll get started here in just a couple of minutes. But we're almost ready. Foxboro IA Southeastern Users Group. I am David Johnson from EOSys. I'd like to welcome you to the Users Group meeting, and I'd like to thank EOSys and Schneider for their contribution to the event. We've put a lot of, I don't think planning is exactly the right word, but we put a lot of hard work into getting this together. And as you can see, we've had an excellent turnout for our User Group meeting. This is fantastic, so I appreciate that. And want to make sure that everybody appreciates and respects the time that's been put into these presentations. EOSys and Schneider have contributed a lot of time and money to it, and we will make the meeting successful, I'm sure. I want to thank you for being here. Last year, if you were here in Chattanooga, and you know, we had it at the Marriott over by the conference center, and we did not have tickets. And so we kept bringing chairs in as the conference went, and we kept bringing chairs in, and we kept bringing chairs in, and we pretty much filled the room, and then we kept people standing in the back. And so this year we did a little bit better organized, and this room is supposed to hold 100 people and be set for it. We sold 98 tickets, so there should be 2 seats available somewhere in this room. Other than that, it's going to be tight. So that's a good response to it. So thank you for that. It means a lot to me that you're here. Now, some of these topics that we're going to be doing are going to be somewhat dry, somewhat technical, and that's just the nature of the kind of stuff we do. But it's important that as users, we keep this going and we keep it as a opportunity for us to share with each other and learn as we do this. So even if there's not something here you can use immediately, I hope there's going to be things here worth knowing. We have worked hard to make presentations that are going to be something that you can go away from this and take something away. You know, should be something you get some value out of. If it's not, you guys, the users, should be giving that feedback to me and Ashley Burks and Galen Hicks and feeding that back into the user group so that we can do a better job next time. Okay? So, and my favorite question for everybody that's got a control system is, what is your least favorite control system? And the answer is the same. It's always the one you got. Everybody's least favorite control system is whatever control system they have, right? So, and we got Schneider here, and we got to be careful not to bash on them too much. So we have a code of conduct as we go through this. And I would like you to just kind of take a moment and take a breath and respect the authority of the chair, whoever's up here speaking. Give them your attention, give them a chance to do their thing. Be mindful of what you say and how you say it. Engage with kind and respect to everybody. Be kind and respectful. Have a welcoming, collaborative environment. If you don't know somebody, introduce yourself. There's a lot of really nice people in this room. I know a tremendous number of you guys from just having been out and doing this so long. But everybody introduce yourself to each other. The badges are color coded. That helps a little bit. The people that are end users or users in general have a gold color on them. The EOSys guys, and we're kind of hosting this this year, have purple. The Schneider people have a green badge. And then the other vendors, there's Weidmuller and Framatome, and some of the others have kind of a gray. So that'll help you identify just, you know, generally who they are. And then, you know, meet each other, talk to each other. We have a lot of people from power. We have a lot of people from pulp and paper. We have a lot of specialty chemical. Those are the 3 big groups. I guess the refining would fall under the specialty chemical and refining petrochem. But they're here, so seek each other out. Try to meet when you can and do that. I'd ask that you be positively contribute to the pace and direction of the meetings. That means don't sidetrack us too much. There are a couple of people from the years ago that y'all may know that aren't here. So, you know, we don't have the Stan Johnson and Larry Wells and people that might, you know, run us off the rails for a while. So shouldn't be too bad. I think we'll be all right. I'd like to start by kind of giving everybody an update on the email list, because that's the way that we communicate with each other the most in this. I mean, that's how we've managed to keep the Foxboro user group going for so long. We started in 1994. I started the email list when I worked at a company in Tuscaloosa, Alabama called Globe Manufacturing. And I went to a user group meeting. A couple of us got together and we said, hey, it would be great if we could share ideas and talk to each other. So I started writing a weekly Foxboro email list. I called it Foxboro News and Comment. It was like a, rip off on the Paul Harvey news and comment thing. And it was invitation only. We started that thing going. And it was a lot of fun because I would write really weird emails every week. People would write me, and then I'd write it back. And like one year, we did, every one of them had a theme, right? For a whole year, it'd be like, well, this will be a Beatles theme, and then we might do one all in haiku and stuff like that. It was like crazy. So I had a lot of those back in the day. Then the list kept growing and kept growing, and I had to buy some software. And then finally, we wound up in 2001. Duke Doe, met him, and Duke said we need to put this up on a list server. And we for a while we had it on one hosted out of Arizona, and then we wound up on the free list server in 2001. And so that's where we are now. And that's where we are now, Foxborough at freelist.org. And it is a very old, unmodern, unhip thing. In fact, we're so hip by being unhip that we're like Pabst Blue Ribbon. We've come full circle, and we're that's the we're cool again. So, but it has a really nice vibe. The people on the list are really helpful. We got a lot of really smart people that contribute. Some of those people are in this room. I know Scott Landry from Foxborough Field Services here. Scott answers a lot of questions people have on field service stuff. He's an excellent resource. Stan Hobbs is in here. He's written answers on the list. Steve Tiller's here. Um, Russ Boulet's not. He's up in Foxborough, but there's a lot of really good resources here. And meet these people and introduce yourself. They're good to know. If you have a question and you want to know if it's been answered, we have from 2001, every month up on the free list, they are archived. You can search the archive so you don't have to ask a question again. It's pretty useful. And I mean, that's by month. So that's every email that the list has seen over the last 22 years, 23. So here are the statistics from where we're at now before we get into the meeting proper. We have 1,153 people subscribed to the list. So when you send an email to the list, that's how many people it goes out to. Okay. We have 235 unique domains. That's different company last names on the email list. And so probably 235 companies, but there's probably a lot more because we have 319 Gmails, 65 Hotmails, 57 Yahoos. We have some other oddball ones out there. So about a third of the list is coming from people's individual email accounts. I'd like to take a moment to appreciate you guys and appreciate Duke Doe, who for 23 years has been running the list for us. He's been the list mom, he calls himself, but he tells you to trim your emails and keeps things going and handles subscriber problems and things like that. Well, after 23 years, Duke is stepping back some, and some of those responsibilities are being passed on to other people so that he can enjoy his retirement, travel more, and not be tied to the list. So I just wanted everyone, if you would, a round of applause. We're recording this for Duke. 23 years working for free on the list, and it's not a lot of work, but now that I'm picking up some of it, it's a little bit of work a lot of the time. So it kind of adds up as you go through it and everything. And we can't subscribe anybody to the list, but due to privacy concerns, so if you want to subscribe, you have to put yourself on there, and you can go there at foxboroughtfreelist.org. That being said, okay, that's the plug for that. Let's talk about the users group. What are we not talking about at this users group? Because there's some subjects that I'm surprised we're not talking about. We're not talking about cybersecurity. We do not have a session on cybersecurity this year. We had looked at doing one, and it fell through. I mean, in the environment we're working and living in these days, I really feel like as horrible as that subject is, we need to spend more time and share more knowledge on the cybersecurity front. It's important. Artificial intelligence. Any intelligence I exhibit is probably artificial, but artificial intelligence is something that is really coming on in the last year and a half, and we haven't seen anything on it from this group. So this is something I'm interested in. If people have conversations around that, I'd like to see us talking about it. Digital transformation, Industry 4.0, DX, whatever you want to call it. We don't have a lot of conversations around that in here. That might be something that we want to start seeing where we can go. Things taking things to the next level. And then the last one is just a pet peeve of mine that's unrelated to DX, but I've noticed that they've got this new thing that they're starting to try to get traction on called industrial transformation. And I'm starting to see this IX stuff, which is a Roman numeral 9, and I just want us to nip that in the bud before that one takes hold in publications and stuff, because that's ridiculous. So, but these are things I'd like to see us, have some conversations around. And with that, I will hand it over to Thad. Here's our agenda for the day, and he can start taking us through the roadmap and doing his thing.
Yeah. Thank you, Dave. Good morning. Good morning. Just a few words from Christian here before we go over the agenda. So hold on one second.
Yeah, thank you all for coming. I'm Christian Perez. I think I met some of you guys already, some of you guys not, but we're very excited to be here supporting this event. I was reflecting last night, if I were a user, why would I come here, right? And just want to share with you guys. I hope, maybe you're in the same boat as I am, right? I believe that, this forum and sharing experience with industries that perhaps are not yours, but being able to leverage what, maybe some people that run water plants or people that run refinery and cross share all that information. I think it's a great experience, that I'm very excited about it for you and also for us as well to understand, what's driving you, right? We have a lot of technical people here, technical specialists from Foxboro, EOSIS. If I were in your shoes, just use them and abuse them, right? The other thing is, of course, we're looking forward to seeing the Foxboro updates, and we're always very excited to hear from Michael and from Thad Frost. And the other thing that we want to hear is opinions on what should we be invested in, right? What is something that you guys need? And we're here, to listen and to, hopefully, put it on our roadmaps. I'm not making any commitments, but that's really what we're interested to hear from you all. So thank you for coming. Without you all, this would not, continue. So we really appreciate your support, and looking forward to a great event. And with that, I'll pass it over to Thad. Thank you so much.
Okay, thank you, Christian. I think what we're gonna do is gonna go around the room and say where you're from and why you're here. And I'm kidding. We're not really gonna do that. But let's do go through the agenda. That was our welcome and orientation topic. I'll go through the Foxboro DCS roadmap here in just a minute. Michael will start, and then follow with the EcoStruxure automation expert. We've got Kadri here to talk, really good talk around high performance graphics and a successful path forward to the high performance graphics. Then we'll have lunch, and I think you'll notice that this year versus maybe some previous years that we actually have a demo floor out there. So that's a big improvement from previous years. It's not just slaughter by PowerPoint. We got some demos here. And then Weidmuller's here. We're happy to have Weidmuller here to talk the PLC5 migration to the Foxboro DCS along with Steve Tiller. That will be right after lunch. We'll have to give the microphone back to David again this afternoon. Open versus open versus open. FDC 280 follow-up. Tips and techniques with David McCullough around conversion. Then we will have a break for the demo area, and then the Electrodynamic controller. Very interesting topic, very interesting name this afternoon, and then we'll have a user roundtable open discussion right around 3:45, and then tonight's dinner is at Taco Mac, which is a short walk from here. It's Taco Mac, and their specialty are wings. It's a wall of beer, okay. So looking forward to seeing you all there tonight, Taco Mac. And then tomorrow we'll just do a quick recap. Christian's going to lead us through a recap, so that's why he's taking notes over there. And then Stan Hobbs and Tronox will talk about alarm management, a success story around alarm rationalization. We'll talk about SEVI, the cloud tied back with Cadre. Bill Poe's going to be here to talk about APC, Advanced Process Control. We'll have a lunch tomorrow, and then Steve's going to talk a little bit about the historians, Foxboro historian of Eva Pi. We will have a user-led Q&A and moderated discussion led by John. Christian's going to help with the closing, and then the better half of the gene pool is going to talk about the nuclear topics. We have a nuclear session led by Framatone and others. So that being said, let's get into the roadmap, Foxboro DCS roadmap. And I didn't really introduce myself. My name is Thad Frost. I've been part of the Foxboro DCS for, this is year 32. I come from Maine. That's my, I guess you can say my side hobbies, or they used to be fishing and farming, and now they're more like, I'd probably say they're more consuming those products at this point in time. So, yeah, I've been part of Foxboro for 32 years. A lot of, I'd say most of the years in this type of offer management, portfolio management, business. My title is I'm the technical leader for the Foxboro DCS. So objectives of this session. There are 4 really. I want you to learn, maybe you already know, why Foxboro DCS. I want you to acknowledge and realize that the Schneider Electric Corporation is still investing heavily into that Foxboro DCS. Thirdly, you have a path forward with Foxboro DCS. Even when we start talking about EcoStruxure Automation Expert, you have a path forward. Even things that we're doing in the roadmap today, you have a path forward. And fourthly, complete your Foxboro DCS grid, your knowledge grid, and we'll see what that is in a little bit here. So first, why Foxboro DCS? 2014, this is actually the 10-year anniversary of the acquisition of Invensys by Schneider Electric. Can't believe 10 years went by that fast, but it was in 2014. One of the things that we realized right away as Foxboro was that Schneider Electric had a huge portfolio, and that the Foxboro DCS fit very perfectly into that portfolio. And we put the Foxboro DCS with the rest of Invensys, with Western and Schneider. The offering became very broad, a very broad offering. And we realized that through our EcoStruxure Power and Process offering, and you'll see some of that when we start talking about the Electrodynamic controller. And I think we actually have one here as well. The other thing that I realized was that the investment into our own R&D organization increased since 2014, year on year. Schneider is investing in the DCS. You know, I think it was 2008 where Foxboro reached its 100-year anniversary. So now, to do some math, we're at what, 116 years of Foxboro. And if you've ever been to Foxboro, you'll see the wall of patents that go along the wall that just go endlessly. A very innovative company, very good company to work for, very advancing in technology. And then there is our, I'll say, ownership, Aviva ownership, partnership, ownership, whatever you want to call it, that helps bolster our software offering as well. So our offerings are great, but the real reason, I think, of why Foxboro DCS is our lifecycle policy, our commitment to our customer, never really leaving a customer behind. You know, being able to port a CP database from a CP10 to a CP280, being able to move a display manager graphic into FoxView and then into Control HMI, migrating 100 series to 200 series without ever having to touch field wiring. It goes on and on about how we try not to paint you into a corner and to make you do a full rip and replace. So I think that's the real reason why. And if you look through time, you'll see throughout the years we've injected new technology into the system while maintaining that future-proof or continuously current philosophy. So, the DCS roadmap and knowledge grid. We're gonna have a 3x3 grid here that we wanna fill out, and this is what our grid is looking like today. And I figured I'd just come out firing this morning. Okay. Let's start in the hardware. Let's talk about FDSI right off the bat. Okay. FDSI, as you know, as you've seen, as we heard in many of our user group meetings last year, innovation days last year, FDSI is coming to its end of its life. Couple things there is that we did a respin project with an FDSI for our Ethernet. You may have noticed in the lifecycle document that we were able to extend that to February 2025. One thing that you should be doing is in the coming months, maybe weeks, these are going to move a little bit to the more favorable side of on the support side. It may be, it'll range anywhere from 1 minute to plus, but it's going to move. It's going to move because I think we're going to be able to support it longer than what we're publishing. So that's one thing. That's two things. We did the respin to get us more time. Well, we're gonna move our support out as long as we can. We're still migrating some customers to FDC 280, and we have realized that the FDC 280 is not a panacea, if you will. It's not always the best option because of fiber, because of remote field bus. So that being said, we are shortly, soon, we'll kick off a new project within R&D for what we're calling the next gen FDSI 2 that will in helping form this next gen FDSI. Now, I don't have a commitment yet to scope, schedule, or anything. But I do have a commitment to is that we'll take your feedback. And then we've got a QR code up here to say if you are interested in helping form the FDSI Gen 2, please scan it now. And I think I'll get an email to say you want to be part of that voice of customer. And I'll leave that up there for a few minutes. And if you don't get a chance to scan it, then come see me afterwards. But we would take your feedback on that. Either everyone's taking a selfie or they're taking a QR code. Good. I'm glad to see phones go up and get that because this is why this is probably the most exciting news I wanted to share this week, and that's why I put it first. Okay. All right. All right. Let's talk about FDC 280. FDC 280 is a controller that sits on the mesh that we have a bunch of different drivers for. We've migrated FDSIs to this. We do have TSAA for our integration with Triconics. We do have Modbus TCP and Modbus RTU as well on this. This was way back in 2016, so this is an 8-year-old product. I talked about the TSAA. We also added the Modbus server back in 2021, and on top of that, in the last 2 years, meaning 2023 and 2024, we added FDC 280 with OPC UA client, and that's coming in a couple of different phases. We did the custom first in March of 23. We're adding the standard, meaning all the drivers will be on the image for that FDC 280, and then we're doing in Q4 of this year, we're doing redundant server. We're doing the same thing with Ethernet IP. and that is making it a standard, making it, we did some earlier releases to do certain configurations, and now we're making it a standard. So it'll be one FDC being able to do multiple protocols, multiple devices, um, and it's a very powerful device. We know it's not cost effective when you're bringing in 2 or 3 points, but it's good if you're doing, let's say, OPC UA client, Modbus, Ethernet IP from the same FDC 280. Very, very possible to do. We're also adding Profinet this year. We're doing that as a custom to start. If the interest is there, we'll do it as a more standard driver. But we do have a lot of interest in doing Profinet on the FDC 280. So this is just a when and a why, and a when and a what and why would you want this? When today we've got Modbus TCP, Modbus RTU, TSAA, a couple variations of Ethernet and OPC UA, Profinet. So this year our investments are heavily into Profinet, Ethernet IP, and OPC UA, getting all of those out to the market this year. FDC 280 is obviously, it's a great solution for Greenfield, and it's also, we've had some success migrating FDSIs in certain architectures. So why would you want this? It helps the migration of FDSIs, the future complex protocols that need the FDC 280, including OPC UA and Profinet. So what they'll do is that completes our first box on our grid. Okay, so we covered FDC 280. We're 1/9 of the way there to completing our whole grid. For the roadmap, I wanted now to talk about upgrading your FCP 270s. Back in, I guess it was 2020, we released what we call an enhanced online upgrade for the FCP 280. And we know that the FCP 270s are in lifetime. We want to be able to help you move FCP 270s to FCP 280s so you can get to that enhanced online upgrade version of the CP, the FCP 280. With that, I understand that when you do an upgrade, when you want to take advantage of a new fix or a new feature of an FCP, your blocks keep running. Your accumulator blocks don't reset. Your sequence blocks don't, what they do? They initialize. They don't initialize in an enhanced online upgrade. The timer blocks don't reset. So once you get to the 280, you can just say, okay, I'm at the 280. I'm going to stay running. I don't have to have any downtime to take on a new feature or a new fix. So it's minimized unplanned downtime. It's more capacity in the blocks. It's more capacity in the object points, and it's more capacity in the number of FBMs. I can tell you there's no plans in the near term for an FCP 290 or an FCP 300. So this is our once you get there, you're good. You're good. We also just invested in putting in some more or the new components into the FCP 280 to address some obsolescence supply chain issues, so we could extend that lifetime even further. And also, the FCP 280 is part of the cybersecurity reference architecture for, I think it's ISA level 1 architecture. So we did talk about cybersecurity. Go figure. This is just a control lifecycle of the CPs. So you see that where the 270 is up there, including the ZCP, or sorry, I'm not in Canada, ZCP 270, and then we'll talk about that a little bit when we talk about Edge IO. All right, we're 2 out of 9. 2 out of 9 in our roadmap. The next thing I want to talk about is the 100 series IO. We've had a long time offering to go from 100 series to 200 series. Anyone still have 100 series running? Okay. So those are moved to mature in 06, moved to lifetime in 2016. We do have the ability to migrate to 200 series without removing field wiring. Why would you want to do this? I have heard that these things just work like forever, right? They work. So why Why would I want to move this? Well, you could. They are approaching obsolete. We don't have an obsolete date yet, but someday they will be obsolete. Um, the potential to use HARP protocols there when you go from 100 series to 200 series. The IPM2. The IPM2, I I believe that the IPM2 has become obsolete. I don't think we can. I think Lambda stopped manufacturing those a long time ago. Um, I'm not sure we have very many left. I think you maybe can count on one finger, and I won't say which finger, but you can count on one finger how many we have left, I believe. So that be warned of the IPM2. Now, how many 100 series? How many 100 series do you think Foxboro has installed globally? There's some numbers up there. Still running. Thought this was water. Cheers. Any guesses? Anyone say E? Anyone say A? All right. I saw this on a TV show. Computer, take away two of the wrong answers. Okay. You can't phone a friend yet. Okay. Any more guesses? Delta. Computer, take away one more wrong answer. All right. And the answer is, if you said D, you were correct. It's 721,000, over 721,000 FBM still running. And I believe my opinion is if it ain't broke, don't fix it type of thing. If it does, then they just keep running and running and running and running and running. Now, don't hang on. Nothing lasts forever but the earth and sky. Kansas. Right. What year? What is it? Recorded in 77, released in 78. Justin, but just so you know that the 100 series, we do have a migration path forward for 100 series. We do recognize that they are really solid. We do have issues with two things. We have issues with the LEDs on nose cones, sourcing those. We have issues with the IPM2. But we do have, once you migrate to 200 series, you've got a preferred solution. And that includes the nose cone as well. Okay? Third of the way home, I want to talk about Edge IO. I know I stood up right down the street last year and said Edge IO is coming in 2023. Well, Edge IO is coming in 2024. We're targeting it for the end of 2024. What it is, I'll tell you what it isn't first. It isn't a replacement for 200 series IO. It's a complement to it. It's not a full replacement. What it is a low-cost, universal software configurable IO, which is a 4-channel group isolated module. Okay? It comes with a system communication module called an SCM. Now that SCM allows us to do a more flexible remote IO architecture than we can today with our FCM. Now, I said Edge IO is not a replacement for 200 series, which it's not, but the SCM may be a replacement for the FCM. And I think I did a whole bunch of different stuff on it last year about the different architectures you can do. But it could allow us or will allow us, because it also talks, the SCM also talks to 200 series IO. It would provide us a pretty nifty path forward for a ZCP270 migration because of the number of drops that the SCM can support. So end of this year, look for Edge IO, low cost, universal IO that talks to an FCP280 today through an SCM, but also look for that SCM to have the ability to talk to 200 series IO. So both of them, they need each other, right? Or the Edge IO needs the SCM, but the SCM can also talk 200 series. Okay? Clear? I don't have a demo. I had one in my office, but I had carry-on, and I had to fit this sport coat in it. But no, I can. So I can say, like, in a remote field box, a junction box, a remote junction box, the one that's like, I think we're doing like 96 IO. So it's pretty good density, and it can be simplex or redundant as well. I could have brought one. It didn't. It would just been on a base plate for size. Probably should have. Okay, so that's the Edge IO. Honeywell TDC 3000 migration. Just this year, we released Honeywell TDC 3000 migration. And what we've done is we've taken our own electronics and we've put them in the form factor of a TDC 3000. And this is a 200 series based migration form factor card. And it happens to be one sitting right here. I stole this from the demo, Steve. I don't know if you had that out there. Graham Bennett. I can't see him. I guess I can hand it around. But anyhow, on the side here, maybe I can even get this on the camera. On the side here, we've got two series compact cards that fit into the Honeywell TDC 3000 form factor. So when a CP looks at this card, it sees a 200 series FBM. From a supply chain point of view, this is great, right? When we were designing this, I didn't even know how to spell supply chain, but now we only have to source 6 components. So the key here is we take out the old TDC 3000, put in the Foxboro card, and then we don't incur any new footprint. We maintain our field wiring, and we really minimize any downtime that we'd have. So this is a form factor and increased function replacement of the Honeywell TDC 3000. Why would you want this? If you're unhappy with the level of support from Honeywell, you can't afford any substantial downtime, you can't afford any substantial footprint increase, you want to maintain your field wiring, you want to utilize Harton asset management. It's a great story. In fact, does anyone want to see this? Hand it around? No, just set it down. I'll put it back, Steve, after none. I mean, this also goes along with our other DCS migration offers, including Bailey 90, Infa 90, Honeywell TDC 2000. We already did a 3000 with a 100 series base, but this is a new TDC 3000. Siemens Moore Apex. We have all these in form factor. Also, no increase in footprint, no increase in downtime, and maintain field wiring. And we have our friends from Weidmuller here today to talk about PLC5 migration. So we've got a lot of different migration paths forward, and we do have demos here on that. You probably saw those walking in for PLC5 migration. And we have a session tomorrow on it. Today. Even better. All right, so we're 5/9 of the way through, which is 55.5%. And then we do have we've got a lot coming out this year. We really do. We've a lot of different things coming out, and I'm still on the hardware. We've got a new workstation, a new server update. The workstation is coming August 2nd, 2024 at 11:07 a.m. Okay. Yeah, give or plus or minus. And then we have an HPE server coming out in Q4. So these are qualified with the latest operating system. They will be qualified with the latest operating system, which I'll talk about in a minute. It will the server hardware will be an HPE ProLiant Dell 380 Gen 11. The operating system for the server will be Windows Server 2022. Comes with some new model codes, so it won't be so confusing. And then throughout the last couple years, or 24 months or so, we've introduced new switches. These new switches, we added the 5520, which is a high performance root switch back in 2022. It supports the switch replacement for the S series and the N series. It supports the 10 gigabit backbone. It supersedes the X460 with a plus or minus 6 months overlap. And then last year we added the 5420 high performance edge switch, which was a generation 3 from Extreme. It was a 50 degree Celsius, 122 degree Fahrenheit switch. It superseded the lower temperature X440, again with plus or minus 6 months overlap in sales. And then just more recently, which you probably may not have heard of, is the Hirschman Greyhound switch in 2023 industrial edge switch, sealed, 70 degrees C maximum temperature. It supersedes the I series and applications in the harsh environments. Okay, so it's a bunch of just things we're doing in the network. Also for the network management software, Extreme Cloud IQ Site Engine XIQ-SE. License per device. It does supersede the net site, which has now been obsoleted and runs on the server boxes. Okay, we are getting there. Also in the hardware, I don't have this on the grid, but we do have this in the demo. We do have this. We do also have a. I haven't seen Darren yet, but we also have a session on this for the Electrodynamic controller, or the SCD 6000. You just keep saying that word, it just flows. Just keep saying Electrodynamic controller. But what it helps us do is remember when I first said why Schneider Electric and EcoStruxure power and process and everything Schneider had to offer. But now this is basically our integrator for IEC 61850 to bring in our medium voltage devices and low voltage devices into the network. So this is something we're very excited about. You may have seen it on the table out there. There is a session for it. I'm not going to steal anyone's thunder, but we will have a complete session around the Electrodynamic controller. Now I want to get into software. Doing good. Software. Control Software 8.0. Aviva System Platform Update. This was released not that long ago. It started shipping February 15th, so it started shipping last week. This is the Aviva System Platform 2023 for the Foxboro DCS on the new Windows OS. It all comes with cybersecurity and lifecycle extensions. Why would you want this? So with the new paradigm, we are allowing upgrade discounts for all previous purchases. We are allowing upgrade discounts for all previous purchases. So that's a good thing. Cybersecurity compliance with that new OS, the new SQL Server, new Excel, new Visio, etc. We have direct migration paths for Foxboro Control Software 6.3, Control Software 7.2, Control Software 7.5. It's going to help to extend the lifetime of the DCS by 5 years. We can now deploy HMI changes without operator interruption and caching of the graphics. So this plays further into our future-proof philosophy. And the new OS. Notice those dates are very similar for when they were released and shipping, because they came as a pair. So the new OS Obviously, we can run this on Windows 10 long-term LTSC, Windows Server 2022. We can obviously run that on our existing H90, H92, and V91 virtual machines. We also have the new options. We order those so we can get the OS kit, so we can also get the boxes with the OS on it directly. New control core services 9.8 with all DCS software updated. Why would customers want this? Cybersecurity compliance, new OS, extending the life cycle by 5 years, avoid costs for that. Remember that Microsoft extended security update packages that Microsoft was selling? First year was okay. Second year got expensive, and the third year got to extortion type of thing. We're not streaming, are we? Oh, okay. Anyhow, future-proofing DCS for unplanned downtime. So that completes our grid. I want to mention a couple more things on the roadmap. One was, I know we have a session on high-performance graphics coming up here at 11. This FoxView to control HMI migration path there are conversion tools that are available as an engineering service, converting our FoxView graphics, faceplates, overlays to control HMI. That's still there. That's been there for quite a while. Also, in 2024, we're looking at an OPC UA server workstation or computer-based, I'll say, for high available, high performance, and flexible real-time communication with OPC UA server. So you'll notice that this whole roadmap is a little different than what we've done in the past, where we did the hardware and the software and the digital services and the digital cybersecurity and all that. So I really wanted to get into things that would help us meet our objectives over the course of this. Like I said, the roadmap does feature digital services, digital offers, cybersecurity, edge control hardware, edge control software. I focused on the bottom two and filling out where our investments were. Now remember what our objectives were for this session. We wanted to learn about why the Foxboro DCS. We wanted to learn that Schneider Electric is still investing heavily into the Foxboro DCS. You saw all the things that we're doing this year. I also wanted you to realize that you have a path forward. There are many paths forward there, including a next-gen FDSI, which will provide a path forward which may not have been there at this time last year, including going from a 270 to a 280, including going from 100 series to 200 series, including going from graphics to HMI. You've got many paths forward to get you where you want to go. And we completed our Foxboro DCS knowledge grid, which was we were 9 for 9, which I didn't have any doubt that we would pass that. So speaking of paths forward, we're now going to transition to EcoStruxure automation expert with Michael Martinez. Yeah. We do questions because you got to set up this thing. Do you need a clicker? Yeah. Yeah, ICC, FoxView, FoxDraw, those, Foxboro IA, Evo, EcoStruxure, Foxboro DCS, it's been around since 87. Like, if I went through the whole roadmap since 87, that'd be like everyone introducing themselves and going through it. But yeah, there is, I know that we're supporting ICC and FoxView at least until 2030 at this point. But I think that's more of a life cycle discussion than a roadmap discussion. It's more of like a support question. But yeah. sneak in? Yeah, you wanna... So the question was, if you're happy with your FDSI now, what would you recommend? Would you recommend going to FDC 280, or would you recommend waiting for like a Gen 2 FDSI? So there's going to be a... Hear me? Oh, there's going to be a time where the FDSI um, 2 release and the level of support, it's going to be I think it's going to be really close to where we're going to support. So what I recommend is look at the life cycle guide in like a few weeks to see where we see where...
Move over to a...
Check, check. Yeah, if you guys want to, woo, hot.
We get 10 minutes.
We got some time. Yeah, if you guys, wow.
10-minute break.
Yeah, if you guys want to get a quick snack, get a quick break right now, I'll get started in 5, 10 minutes when you guys come back. 10 minutes, 8 minutes, 8 minutes. Check. Yeah, I know. You gotta tell people they have 5 because they'll be back in 10. So.
Hit it. Oh, it says it.
run one of these things. It's great. So, your thing, how okay.
Because I think it was supposed to be 10:15 to 11. So
Yeah, it's 45 minutes yet. Perfect. Okay. Okay. It looks like they're bringing in some more chairs. So, yeah, yeah, we sell them out. My goal is to one day be a concert promoter. This is where I'm starting. I'm starting small. Okay, if the tech guys are ready and everything, we are going to turn it over to Michael Martinez with Schneider about the EcoStruxure automation expert.
All right, thank you, Dave. So I'm gonna come back around to a lot of the topics and themes that Dave and Thad have actually talked about before. But before I get started, I'll introduce myself. My name is Michael Martinez, Michael J. Martinez, MJ. I may have started some of your plants. You may have known me for a long time. I've been with Foxboro, started in '97. So I started in the delivery side, worked my way through probably every type of consulting we have, from alarm management to cybersecurity to digital transformation. So I've worn a lot of hats for the company. Back in 2021, so in January of 2021, I became the global DCS leader. So I'm responsible for all of the Foxboro distributed control systems offers that we have. So that's part of my team. I also have another part of my team that's focusing on the next generation of Foxboro DCS. So that's what I'm going to share with you today, a little bit about kind of where we're going with that, how this ties into some of the open standards and some of the other things you're hearing about from an industry standpoint. And at the end, I will have time for questions, so make sure we get there. So one of the things that Thad mentioned in the beginning was all of the stuff that Schneider Electric brought to the portfolio when they acquired us in 2014. One of the things that in one of my many roles that I had before from a digital transformation perspective was to try to explain EcoStruxure to customers right after the acquisition. So right after Schneider Electric acquired Foxboro and right after we started to kind of fit into this big 3-layer cake view that Schneider had of the world. So in 2012, so actually before they acquired Foxboro, before they acquired Advensis, they had introduced this concept they called EcoStruxure. EcoStruxure for Schneider Electric is basically their industrial Internet of Things framework. And so as they looked out into the marketplace to help to determine how could they actually meet all of their customers' energy and automation needs, they started to identify gaps. And there again, that's kind of where the Advensis portfolio fit into that acquisition. But as we started to talk to customers about it, say, yeah, everything from connected products, so all of the stuff that actually touch the process to the controls. So traditionally what we think about DCS, PLC, safety systems, and then that software layer, apps and analytics. In the beginning, we would try to explain, well, this is kind of a vision. This is something that Schneider Electric has aspired to make real in the world. But at the time, it really wasn't, right? Because you had all of these different vendors. You had Viva on the top. You had all of these, instruments and connected devices down at the bottom. You had many, you had Modicon, Foxboro, Triconix. You had all these different systems that were there that all had their own configurators and all had their own hardware and all had their own separate ways of managing and maintaining the systems. But today what I'm going to share with you is kind of how that vision has evolved and how EcoStruxure now is no longer just a term, it's actually reality. EcoStruxure Automation Expert is actually the integrated development environment that will allow you to create applications that can be deployed at all 3 layers, okay? So if you think about today, as I said, if you have a PLC, if you have a DCS, if you have an intelligent device, if you have a software application, you have to manage, maintain, configure all those things, maybe put in gateways and translate data from one to the other and manage another piece of hardware and another potential point of failure. EcoStruxure Automation Expert starts to break down those barriers so that we can have one common development environment to create applications for all of these devices. So let me share with you a little bit about the foundational technology. But first, before I get into technology, a couple of years back, we had Omdia do a survey on our behalf to kind of understand what were end users like yourself, where was the industry going? And one of the key things that we found out, and it should have been obvious, but is that 80% of the different industries, so we surveyed several different industries, considered open and interoperability an important capability. So what is this all about? This is really meaning that as you look at your facilities or at the plants where you operate, if you have multiple systems, if you have multiple vendors, managing and maintaining those different systems, the interface of all those different systems, the life cycle of all of those different systems, the ability to, say, take an application from one system and transfer that application to another system, that's a problem. That becomes your full-time job, is actually managing the technology and not actually getting the best out of your processes. And so I know when I started, I mean, I'm an engineer as well. It was always about how can we get more out of the process? And slowly my job migrated. That's why I said I became a cybersecurity consultant. Why? Not because I wanted to, but because of necessity. Because you guys were being driven to meet certain cybersecurity requirements, and we had to figure out how to make our OT systems capable of addressing those vulnerabilities. All right, so now we're kind of getting back to the other end. How do I make sure that as I invest in technology, that it's going to allow me to work with the other systems that I already have in my plant? So two things were necessary. First is what we call universalautomation.org, and this is actually a spin-off of Schneider Electric. Universalautomation.org owns the runtime. So if you think about it as the Android operating system of OT systems, it is really that real-time operating system that you can develop applications on that is independent of hardware. Okay, there again, in that Android model, there's many manufacturers that make the hardware. As long as it's running that Android, you can download the apps from the store and transfer apps from one device to the other. So they really own that runtime. And what Schneider recognized in the beginning was that every time that we've tried these open type of organizations, whether it's Foundation Fieldbus or Profibus or Profinet or any of these things where we try to share, it always required one vendor to concede to another vendor, right? I'm gonna do this, but now I got to go work with Siemens, or I got to go work with this organization or that organization, right? So we decided to spin it off, to give it away, right? Nonprofit organization, independent from Schneider Electric, that owns that runtime. Okay, there are user members, and I'll go into a little detail on that, but that was important to have that open platform for those applications and other hardware manufacturers to be able to make products that can actually run that runtime, and that'll become important. I'll show you why here in a second. The other piece is Schneider Electric. So what did we bring to the table that was of value, right? So obviously, if those of you who are running Foxboro systems, you're hopefully at least familiar with and aware of the interface that you work with, the configurators, the experience that you get in working with Schneider Electric, whether it's on a Foxboro system, Triconix, Modicon. How do we take that experience and encapsulate that to allow you to create applications and continue to have that experience on different types of hardware, right? So we have two aspects here. So one is that EcoStruxure Automation Expert, which I say is the integrated development environment. So it allows you to create those applications. The other piece is what we call a soft DPAC. It is a containerized controller. So this becomes important because this is actually what allows you to be able to take if you think of it as your FCP 280 today. Imagine if you could take that like we did with music. So digitize your music, and now you can transport it from one device to another, experiencing it in all of these different ways. A containerized controller allows us to do that. And I'll show you some real life video of how we're doing that today. So if you have that containerized controller running on a piece of hardware today, that piece of hardware fails, you just move that workload over to another device and it continues running. And it's not dependent on the hardware. It's just like your MP3 file, your digital music file. You don't lose it just because you lose your player. You just go play it on something else. So these elements became important, right? So let me show you just a quick video about what is EcoStruxure Automation Expert.
Meet EcoStruxure Automation Expert, a new category of software-centric automation for the digital world. Today, automation engineers use many tools to design an industrial automation system. Without a common source of data, they must manually repeat tasks from tool to tool and discipline to discipline. It's not efficient. EcoStruxure Automation Expert creates a complete digital lifecycle for your automation system. Engineers are free to design processes independently of the automation system. Once the design is complete, the engineer deploys the application on the hardware in just a few clicks. Applications are automatically distributed. Any changes can be made with zero automation engineering. EcoStruxure Automation Expert makes it easy to design your automation control system, and you can easily connect a digital representation of an asset to its real-time control. Using this digital twin, testing and adjustments can be conducted in a virtual environment. Commissioning time is reduced. You're up and running faster. Market demands change fast and often. To keep up, manufacturers must be agile and modifying equipment quickly and easily. When market demands drive your plant to its limits, EcoStruxure Automation Expert makes it easy to generate additional capacity. Production assets can be added with a simple drag and drop. EcoStruxure Automation Expert is a new category of software-centric automation. Bring your operations into the future today. EcoStruxure Automation Expert can help you keep up with the speed of doing business in the digital world.
I hear that sound in my head when I sleep. Every video starts and ends like that, so I think I should make that my alarm clock sound. So EcoStruxure Automation Expert. So what's unique about it? As I said, obviously they talk about the value props at the top, the engineering efficiency, operational effectiveness, and future proof. A lot of that comes from the fact that it's software defined, right? So we're getting away from the systems that are hardware dependent, having embedded controllers. So today, for example, when you open up your FCPs, you open up the memory, you write the application, it's bound to that piece of hardware. Now that we're talking about developing applications and having automation that is effectively software, you can do all of that offline, right? So from an engineering efficiency perspective, one of the things that they alluded to there is that we can get information directly from other digital systems. So I'll talk about how we're using that in the next couple of slides, but this means that we can work with anything from an Excel spreadsheet to a digitized PNID to a digital twin to be able to bidirectionally share information so that not only is your automation system efficiently configured without the need for, or the opportunity, I should say, for human error and human entry problems, but also bidirectional in the sense that as you make changes or updates to your process system, that those updates are pushed back to your modeling. Right, so if you have an operator training system, for example, that's using that same model to pull from to train your operators, they're all updated simultaneously. So it eliminates that need to do takeoffs from a drawing to then convert that to a spreadsheet, to then convert that to a configuration, to then convert that to graphics. Everything about EcoStruxure Automation Expert is integrated. So something else that's very unique about it that I'll show you on the next slide is that we configure the logic and the graphical element together. Right, so then when you pull from a library, you're really pulling everything from a logic standpoint, a graphic standpoint, so you're building your configuration and your graphic at the same time. From an operational effectiveness standpoint, because it's based on software and because it's leveraging what we call 61499, these are event-driven type of logic. This is actually how most of our IT systems work today, right? They're transactional, so we have to create an event, and then that event triggers a workflow, and that workflow does something. It's been difficult for us, so many times we'll have to create a separate piece of software in order for us to tie a cyclical time-based system like our distributed control systems today and PLCs today to an IT system. We have to create some type of software or something that creates a trigger, that creates a workflow that executes. Because this system is natively event-driven, it's very easy to actually interact with IT systems today. And we actually have several. Now I'm gonna talk about artificial intelligence. So we're gonna cover that one. Artificial intelligence. One of the things that we are doing, because we have the containerized controller, is now we can run standard control like we do today, right alongside artificial intelligence in another container on the same device, either at the edge or having that artificial intelligence, whether it's a machine learning model, to learn particular behaviors, or if you're actually trying to tie it to a larger artificial intelligence model that maybe you have running at your corporate level or even on the cloud. So now that all becomes possible. And then future-proof, what I mentioned, is really about the fact that it's software-driven. Getting back to that analogy of music, really now you've digitized your automation experience. The controller is digitized, the configuration is digitized, the graphics are digitized. So now you can take that wherever you want. You can take that, you can throw away that old piece of hardware and now continue to experience your library of automation, your automation experience on different types of hardware. So from a future-proof perspective, you're no longer bound. So when the hardware becomes obsolete or you can't get it, talking about supply chain, if you couldn't get that controller, if you can get a computer that meets this, minimum specification to run the software, you can run it on that device. So another important thing to remember, as I said, because it's hardware independent, you can actually now do all of your testing, all of your development, even developing type simulation models offline, as long as you have a computer. You can test all of that, test the applications, test the interface, make sure that you're doing all your factory acceptance testing, operational testing. And then whenever you get to the facility, you just distribute or deploy the application where you need it. This is where it gets a little different from a paradigm that we think of today, because we think of breaking our controllers into, our logic into controllers, into hardware, right? At this point now, you start to think about, well, where does it make sense for this particular application to run? If I have an intelligent device, for example, if I have a drive or something that's more local to, say, where the flow control or whatever, it may make sense to actually run that part of the application there. It may make sense to run other parts of the application in different locations. You're no longer bound to hardware. So you're no longer bound to say, this entire application has to fit in that processor. I can split the application up. I can deploy parts of it here, parts of it there. Right? So it becomes very powerful in the sense that we can select the right hardware for what you need, whether it's based on the environmental conditions that it has to operate or based on price, quite honestly. But if you're looking for a lower cost, something that fits the environmental needs and fits the performance needs that you have, that you can get at a lower cost, use the lower cost hardware. There's no reason to buy dedicated hardware. And that's why you'll hear me start talking about how we're moving from embedded dedicated systems like the Foxboro DCS, like a PLC, like a SCADA system, like a Machine Solutions, to a spectrum of controllers that can meet all of your process needs, that can be deployed as necessary based on the applications that you have, independent of the configuration. So you put the right hardware in the right place and you just deploy the software. And there's a lot of organizations that are kind of been driving towards this. Historically, if you look at Namur Open Automation, OPAF, I know Dave's going to talk about this a little bit later, so I don't want to go too deep into that. But one of the things that had always been kind of missing is, how do we actually deploy some of these concepts? How do we deploy an OPAF system? How do we deploy an open automation or a Namur Open Automation type of system? So that universal automation, that runtime, gave us a technological platform to actually start developing some of these systems. And so what makes it unique, and as I kind of mentioned before, is that if you look on the left-hand side, today we can actually make OPAF systems, right? So we can make a system that aligns with the standards, and there are many out there, where you still take multiple vendors with their own systems, with their own hardware, and you build systems that communicate to each other. Because standards like OPAF really set the communications protocols. We have a standard way of sharing information. We have interfaces. Really, it's really about that interface that's getting defined, and not the how, but the communications layer. The difference between that way of complying with those standards and the universal automation way, as I mentioned, is that you have that one integrated development environment. So you're not having to manage all of the different tools. You're actually creating one set of applications that you can deploy on different hardware. So before I get into how we're actually deploying it today, I wanted to answer the question, so what does this mean for Foxboro? So Thad just gave us the Foxboro roadmap, and he mentioned that one of our values as a company is that we never want to leave our customers behind, and we always want to make sure that there's a path forward for you. So probably about, when did I start? Like 2021. So when I first took this job, right, we have to start talking about the future, but we have to make sure that we talk about the future in a way that connects to the customers who are actually using our systems today. So this is a slide that's been around for years, but the important thing here is, as Thad mentioned it before, is that we're continuing to invest in the Foxboro DCS, right? We need those capabilities. You guys need those capabilities to operate your facilities and continue to get out of your processes what you need to get out of. But as we move to this idea of this universal automation type of world, we're also investing in EcoStruxure Automation Expert, right? EcoStruxure Automation Expert, just so you know, has been out since 2020, okay? Our first release was in the fourth quarter of 2020. It's running in hundreds, if not thousands, of plants today. But we intentionally started deploying it at the lower scale, less critical, things that don't go boom type of industries, right? So if you think about the customers who are using it today, these are customers who are Modicon customers. Remember, I mentioned that this is going to be a single integrated development environment for all of our automation solutions. So Modicon has been deploying this at the PLC type of application, PLC level, since 2020. So we have a lot of experience with it. It's being developed in an agile way. So what that means in normal terms is that we do 2 releases per year. And in between those releases, we actually get feedback from end users like yourself on what are some of the capabilities, what are some of the features that you want to see added, and that gets put into our cycle, right? So that every 6 months we get a new product with new features, with new updates, with new capabilities. So we're just now at the point where we're comfortable saying that EcoStruxure Automation Expert has some of the capabilities that we would start to look for in a continuous control system, a DCS, right? It's had the PLC stuff for a while, but now we're starting to add features for DCS. And so at that point, we'll start to consume EcoStruxure Automation Expert. But because it's software, it's not replacing Foxboro, it becomes the software layer of the Foxboro DCS, okay? So what does this transition look like? So it's really going to be in 3 phases. So first, what can we do today? As I mentioned, EcoStruxure Automation Expert, as it stands today, is capable of doing some pretty interesting things. But primarily, you guys would think of them as things you might do with your PLCs or with a hybrid DCS type of solution, right? So a really PLC network type of architecture. Today, you can actually replace those PLCs with PLCs that enable us to run EcoStruxure Automation Expert and the applications that we can develop with that configurator. The way that we tie that into your current generation Foxboro system is the FD C280 OPC-UA client driver that Thad was just talking about. Okay, so right now, another unique feature of EcoStruxure Automation Expert and that soft DPAC, that soft controller, is that it uses OPC-UA for communication, right? So they're again kind of looking forward into this, how we adopt standards as a way to create applications and create our future technologies. The next step will be coexist, right? So I'll ask, how many of you are familiar with our address translation station, our ATS? Yeah, good. So the address translation station allowed us to do something that was really fun and interesting at the time, which was to be able to bridge an older technology with a newer technology. At the time, it was node bus to mesh to the systems that we have today. And so it allowed those 2 systems to coexist so that as time progressed, as life cycle required, as you had your turnarounds, as you had opportunity and budget, you could slowly migrate the things from the older system to the newer system, but they were allowed to coexist. So you could, from that newer system, so here I'm showing that main plant operations kind of down on the bottom, you could actually operate your facility with the single operator interface. So you didn't disrupt your operations, but you allowed in the background that technology to be replaced and modernized with new technology. And now most of the systems are running on the mesh, the Windows systems. Okay. We're going to take a similar journey now with what we call the EcoStruxure Transformation Station, which allows for the current system, so that mesh system, to coexist with one of these EcoStruxure Automation Expert-based systems. Okay, I'll give you a little bit of detail on that here in a second. But the idea is no rip and replace, and as we get to more software defined, no need to replace all the hardware. Replace the hardware as it becomes necessary over time, and as you find that either you need additional capabilities in the new system that the current system doesn't allow for, or that you just can no longer get the hardware anymore. Eventually winding up at a universal automation-based type of Foxboro DCS platform. So I'm going to go into a little bit of detail right now just on how we intend to do that transformation. So I'll keep going year after year. You'll see me probably in next year we'll actually show you some of these technologies, because these are also, as Thad mentioned, we're investing in the current system. We're also having significant investments in this next generation system. So as I mentioned, this is the first piece, that EcoStruxure transformation station that allows the two systems to coexist. This is as you go from having completely nothing on EcoStruxure Automation Expert, slowly over time transitioning everything over to EcoStruxure Automation Expert. The next piece is actually how do I migrate, right? So, there was a, FoxView to control HMI, how do I migrate code? We have a tool called EcoStruxure Asset Link, which is actually allowing us today to take digitized drawings, to take Excel spreadsheets, to take our Aviva digital twin information and build current generation configurations. That'll be adopted to convert to EcoStruxure Automation type of configurations. And eventually, one of the inputs that EcoStruxure Automation Asset Link or EcoStruxure Asset Link will actually take is a Foxboro configuration. Because as I mentioned before, one of the unique things about EcoStruxure Automation Expert is that the configuration and the graphics are built together in something we call a composite automation type, or a CAT. Okay, so when you go from your current configuration to a new configuration, you have the opportunity, right? So I should say you must, but you have the opportunity to say, let me take advantage of this new tool in a way that allows me now to map to assets as opposed to a flat file. So today, when you think about compound block parameter, that's really a flat file type of structure. We didn't really build those in assets. Some of you may have tried to think ahead and say, okay, well, I'm going to make a compound an asset, but there's all different manners of ways of configuring those systems. With these new systems, we can actually map those compound block parameters to these composite automation types that are really assets. So it could be a pump, it could be a reactor, it could be however you break your assets down. This allows us to now get more value out of future systems because now we can take advantage of things like you see Aviva OMI is kind of the graphical part of this next generation system. And what that allows you to do is because they're asset based, they allow you to get additional context, right? So you can give geographical information to assets. You can give vendor information to assets. You can now give more context to an asset than you say can to a compound because because it's a flat file, we can't just add additional fields and say, well, where is this at physically? Give me a geolocation. Can I get the temperature at this particular asset? All that type of information now becomes available because we can start to use asset models in this next generation of technology. And so Asset Link allows us to build that bridge from that present flat file to that future asset-based type of architecture. Watch my time. Eventually arriving at an architecture, if you have a current generation system, your architecture may look something like this. So let me see if I can get a pointer here. Because there's a few things I want to point out. So one is you'll see Schneider Electric head units. So one of the things that Thad mentioned was that with the 100 series to 200 series migration, with the TDC 3000 migration, with all of our migration offerings, one of our primary intents is to never ask you to lift field wires, right? We never want to say do that because we know that's one of the most expensive things that you can do from a time perspective, from a labor perspective, is lift all the wires and reland all the wires on your I/O modules. So what a head unit is it actually allows us to incorporate pretty much like that migration card that Thad was showing, just to hijack the I/O bus, take over those modules, and keep communicating without having to lift any wires, right? So what you'll see here is our Modicon Edge I/O. So if you have PLCs, and I think we were talking with some other folks the other day, how can I start to replace my PLCs and not just have to update them and not continue to get value out of them, but then incorporate them, say, into a future architecture? Put a head unit on there and tie this into EAE, and this becomes a pathway to that future system. So remember, going back, now I can use OPC-UA to talk to my current Foxboro system, and then eventually, as I start to migrate some of my Foxboro hardware to EcoStruxure Automation Expert, it just becomes one control layer, right? So one application that I just keep expanding. The other thing you see down here, and this would be new, is Ethernet APL. How many of you have heard of Ethernet APL or are exploring Ethernet APL? Okay, yeah, I didn't think so. APL stands for Advanced Physical Layer. So what this is in our terms from a technology standpoint is it takes power over Ethernet and cranks it up a little bit for our application. So basically, it's inherently intrinsically safe. So and it's a way for us to get Ethernet into the field. So it's very new from a technology standpoint. I think they've been using it in automotive. That's where historically it comes from. But they're using it now. We're looking at how to get it into the field, primarily because there's been a lot of demand for more data from intelligent devices, from information that you can get out at the field or the edge, however you want to define the edge. It keeps getting lower and lower. Uh, to get more information from out there. So we put Ethernet, so to give us a conduit to be able to get more data from those types of devices. And so Ethernet APL, or Advanced Physical Layer, is a network layer that allows us to do that. The other thing I want to point out is this Schneider Electric Unified Controller. So one of the things I have here, and I'll show you where it fits into the future, is a next generation controller. So this, in OPAF terminology, is called the Distributed Control Node, or DCN. So we collaborated with Intel to develop this. It's based on Intel technology. It's got Intel chips in it. One of the unique things about it is that this piece here with the heatsink on it is modular, right? So if you ever need to replace it or you want one with more power, you just snap that off. You don't touch any of the field wiring, the power, or the Ethernet. You just change this module out. Okay, I'll show you guys where that fits in a future architecture here in a second. But there will be a family of those types of controllers. Yeah, you can pass it around. This one has real electronics in it, so please don't break it. But the idea with that, so that this starts to become part of that spectrum of control. So everything from that small machine solutions high-speed controller to a PLC to a DCN, now we call it distributed control node, all the way up to what you see here is a soft DPAC running in the cloud, running on a micro data center, even locally. So we're kind of in that transitional phase, and I always go back to the music analogy. We're in that transitional phase where we have iPods, right? I don't know if you guys remember that era. I probably still have an iPod in my desk somewhere in an office. Whenever we still needed something physical, because we went from the stereo to the Walkman to the iPod to now we just listen to music on our watch or whatever you have that streams music, right? And we're kind of in that iPod era, meaning we still have a lot of infrastructure. We have a lot invested in infrastructure in our facilities, and so we still need a piece of hardware to host and run that control. And there are other reasons. I mean, obviously there are operational risks associated in analysis that you guys go through to say, where does it need to run? How available does it need to be? How close to the process do I want it? So there's still a need for hardware. But there are some industries that are starting up now, some applications that don't have control rooms. They won't have control rooms. You know, I think about, you know, some of the things like carbon capture. If you're talking about, like, say, direct air capture type of technology, these could just be small units or small gensets, right? Small jets where you're just going to generate power. You're not going to have a control room. You can actually run this control both in the cloud and locally. And some of these customers that we're talking to now want to actually run the control primarily at the cloud, so on their local cloud level, because they can manage it all centrally, and just have the hardware on at the device or at the unit level, I guess I should say, as a backup. That's another interesting thing now that we think about having software controllers, is that how we think about redundancy is changing, right? How many of you wonder, you know, what will happen if one of the Netflix servers goes down? You will never know, right? You'll never know. Because of the way that they distribute their load, the way that they distribute their control in their applications, similar technologies now we're deploying in these types of applications. So if you think about it, we can have a cloud controller, that soft DPAC, that containerized controller, backed up by a local controller in the field, and they're acting like you would think of today as a fault-tolerant pair. They're just two different pieces of hardware, two different locations. So that's a unique thing that's coming around. The other piece that gets interesting too is, as I mentioned, universal automation. We're not tied just to our own manufacturing now. Now you can adopt technology at the speed of innovation that these different vendors are actually creating new technologies at. So if they create a new device, you can just bring that into your system. You don't have to wait for Schneider Electric to come out with a new product. As long as it supports the software, and because they're part of universal automation and they're creating UAO compatible devices, you can just put it in the system. You don't have to ask. So how does this fit into the future? So kind of as I mentioned before, with the software-defined applications, this is really fitting into that marketplace of what OPAF is looking for. Because overall, they're looking to make sure that one of the primary drivers for the initiation of OPAF was hardware obsolescence. You know, we had a large vendor, a large customer large end user, had a significantly large install base that was going obsolete in the near future, and they were probably going to have to spend billions of dollars replacing it. Okay, billions with a B, right? Because so many plants, and they had put in all these plants at the same time, and now obsolescence was going to drive them to replace a system. So I said, well, how can we make sure that when we invest in that next generation of technology, that we don't find ourselves here in this same place 30 years from now, right? That we don't get locked into one vendor, that we don't get locked into these vulnerabilities or susceptibility to supply chain issues. Right? How do we make sure that our dependence on these technologies, because they do feed a primary function in your facilities, isn't a vulnerability to us as our operations, right? So they started looking for ways to standardize, to create these open, and OPAF was one of those standards, right? But the intent was actually multifold. So in addition to dealing with the supply chain, how do we get costs down? How do we get time to market down? So as I said, how do we start to incorporate new technologies faster so that when I see a really neat thing, because that guy in the back there is working on a really new idea, how do I get that into my plant in a way that doesn't require me to create new drivers, new interfaces, go back to this vendor, have them added into their product? It's a whole new way of thinking, right? So this is what the OPAS architecture looked like. I'll skim through this real quickly because I want to make sure I keep the time. But these are the distributed control nodes, and some of them have applications, some of them are virtual. So the advanced compute platform, that's kind of that cloud. So you can probably see I intentionally drew up my slide in a way that reflects the architecture of OPAP, because that's where we kind of see a lot of things going, right? Now, I want to be very clear. This does not mean that your future Foxboro DCS will be a multi-vendor solution. It's just saying that it can, right? It's just saying that it can. So if you decide you want to stay with Schneider Electric, and I hope you do, that we will have all of the hardware, all of the software, all of the capabilities, and from that first EcoStruxure drawing that I showed you, the ability to incorporate everything from our intelligent devices to our power and process systems to all of the software that you have from Aviva. That's going to come, right? That's going to be the Schneider world. Now I'm talking about how do we play with where industry is driving towards open, towards OPAF, and towards near open automation and stuff like that. And so you may have seen this in the last couple of years. I think last year, if you were here, Dave DeBari actually gave a conversation. You got the slide too? The slide's everywhere. If you were here last year, Dave DeBari actually went through this, so I won't spend a whole lot of time on it, but only to say that this starts to show a picture of a multi-vendor solution. So remember when I said there was a big customer? Well, it was Exxon. They talk about it all the time, so I guess I can use their name. But they have a bunch of different vendor systems in the field, and like, how are we going to start to replace these things in a systematic way without having to take a huge, outage and replace them all at one time? And so they started to run these models. And so this is from a little while back. So remember I said UAO, or Universal Automation, was a spinoff of Schneider. So at the time, they're still showing the Schneider icon here. This is their slide, not mine. So they show Schneider Electric down here on all these different pieces of hardware. What this is representing is they actually took that real-time operating system. So at the time, it was called EcoRT. Now it's Universal Automation Runtime. And they deployed it on all of these different vendors' hardware. Okay? Still with their I/O subsystems, still with everything that they had running, but they went and created an application with EcoStruxure Automation Expert that's running on all of these different types of hardware. Now, at the time, and something's changed, something important I'll share with you. At the time, these were all embedded controllers. So these are like our FCP280, right? This means that the OS is actually running on the hardware, and that when you deployed that application to that piece of hardware, it was kind of on there unless you physically relocated that piece of application. Exxon has actually switched to a containerized model because they don't want anything to be relying on the embedded hardware. It's just one more thing binding you to a particular vendor. So they say, if we can own the software, so they're actually going more towards having these soft containers running on different types of hardware. So what's unique here? So everything here on the left-hand side, this is what you would normally see, you know, your Siemens system, your Yokogawa system, your ABB system, where the I/O is actually tied to the, or over here, where the I/O is tied to the controller. Here, some of these green ones, it's kind of hard to see in the color. Maybe you have a better picture of it, David. In the green, this is actually Ethernet-based I/O, right? And then over here on the right, all these kind of golden colored, orange colored outline. I'm a Texas boy, so that's burnt orange for me. This is the outline is actually there. It's just compute capacity. Remember I was saying that you could actually split your application up? Well, if I need a bigger application or I want to run artificial intelligence or machine learning models, I can just put more computers on the network. I can just split that application more and more and more and more, and dedicate different parts of the application, different pieces. So now all of this Ethernet-based I/O is actually getting its control from these devices. So these either dedicated compute devices or from these shared or what we call bound I/O type of devices where the I/O is bound to the controller. They can also write to this Ethernet I/O, so you're sharing data back and forth between all these different devices. As I mentioned, Exxon's kind of moved to containerize because now, and I'll show you why here in a second, is because of some of the things you can do with containers. So what's possible today? So this is this is actually in Cahors, France. So if any of you guys want to go to France, let me know. I'll join you. And we can go explore our development labs that are going on over there. But what this is actually showing is a lot of the Schneider Electric components, so our controllers, our M580s, some of our Harmony P6, so some of those industrial PCs that we can run applications on, but it's also starting to show something different that Schneider doesn't normally demonstrate, which is third-party systems incorporated, right? So this is a Phoenix Contact controller. These are ASRock controllers. You can buy these from, you know, your local technology vendor, right? They're just industrialized PCs that can run now this containerized controller EcoStruxure Automation Expert. So now I'm going to show you, I don't know how many of you were at ARC a couple of weeks ago, but I'm just going to show you a quick video of what's possible. And this is kind of starts to explain a little bit why Exxon's moved to that containerized version of the controller.
Hi, I'm Rob Chavez from Intel Corporation. I'm excited to bring to you today our next generation smart factory, bringing together technologies from Intel, Schneider Electric, and Red Hat. Today we're going to have a walkthrough of these technologies from Jeremy Ouellette.
So what we have behind me is a simulated environment with a water tank here simulating oil and gas industry. We're maintaining the top water tank level with a PLC. In a typical environment, you would have a hardware PLC. What we're going to do is show how that's been migrated to a software PLC and how you can achieve high availability of a software PLC in a software process automation environment. What we have here are what we call distributed control nodes, DCNs for short, a server running Ansible controller, and we're going to be deploying that software PLC as a container workload onto these DCNs. I will now introduce the software failure by actually disconnecting one of these DCNs, and what we'll see is how the remaining workload becomes single. There's only one instance now. Ansible controller will detect that there's only one instance and deploy another. And when it does so, it'll reestablish communication and enter high availability mode and will be fully redundant.
I don't know if you guys picked up on it, but what actually happened here is that he had, in the 4 distributed control nodes that he had, we actually had the code running in 2 of them, right? So a containerized controller running in 2 separate pieces of hardware. When he powered one off, the system recognized that it was single, so it actually redeployed that other containerized controller to a different piece of hardware. So remember I mentioned you'll never know if Netflix server goes down? It's because it just keeps redeploying and redistributing to all the compute capacity that's available. That's what happened here. We use that Ansible, that orchestration layer from Red Hat to actually manage those containerized controllers and workloads so that as long as there's spare capacity in your system, it just goes to that other device. You can take that failed device, put something as good at the same or better than right there, and either force it back or let it keep running there until it fails back because the other device fails. there again, it gets to the point to whether or not you actually want that application running locally there next to the process for some reason still, right? There again, there's a very paradigm shift in why does it need to be running right there is as long as the network's not there. So you can start to think about, like I said, availability in different ways. But it there again now gets us to start thinking new ways. And so this is part of why I think Exxon was looking at use the container route, because in the old route, if that had failed, the logic was running in that piece of hardware. You can't manage it that way. You can't orchestrate it that same way. Yeah. Yes. No, so it's actually called a Docker container. So a Docker container. Yeah, I a lot, like you said, throw out too many terms I hear bouncing around in my head. So Docker container technology basically allows you, it is almost like a virtualization, but it allows you to actually containerize a computer, if you will. So it's got the operating system, the application, everything running inside of that container itself. And so that you can move it on independent types of hardware. So right now, you can run it on Linux or Windows. I didn't point that out either. But so right now, these DCNs, wherever it's at running, they're running a Linux, a version of Linux on them. And that container is just hosted on that Linux. But everything that container needs, like I said, it's like if you were to take the brains of an FCP280 and put it in a little containerized ball and just allow it to bounce on different types of hardware. So what this is, and you'll see this outside also, is another QR code. We really love QR codes these days; they're great. This QR code, though, however, comes with some potential freebies, so you might want to scan this one. So this is actually, so that DCN that I'm passing around, those are pre-production level devices. We are manufacturing several of those, and primarily what we're looking for is feedback. So what this QR code will do is that it's actually going to ask you to enter email. If you just want more information on participating in our beta program for those DCNs and the EcoStruxure Automation Expert, you can just scan it and send that email. But if you have other questions related to EAE or our next gen system, feel free to write it in there. That's going to a monitored email, so we'll get all of that information and get back to you. But what is the beta program, right? So it's really to get one or two of those different devices into your labs, into a non-critical application. If you are interested or want to start down this path of an OPAF type of system, OPAF, these types of technologies. As I mentioned before, though, these are pre-production units. If you're ready to go on EcoStruxure Automation Expert and you actually want to deploy these in applications that you might rely on, even smaller, less critical applications, you can run it on other hardware. So remember, this OPAF hardware, don't get fixated by the hardware. This OPAF hardware is really to align with the vision that OPAF has for eventually interchangeable hardware. So this will be the final step in the OPAF hardware standard. Right now, they're defining the connection, and that actual DCN right there is built on a reference architecture that was submitted to OPAF for validation, I'll say, that aligns with their standard. Now, the OPAF standard for hardware design is not out. It will probably be years before that piece of it's out. But once that finally gets out, that will be the design that every vendor will be asked to manufacture a distributed control node in, so that they're interchangeable, meaning that you can, if you don't like mine, you can take it out and put a competitor's DCN right into that same slot. That's where OPAF is driving. But so if that's not where you're going, if you're not so into that OPAF stuff, but you really are interested in this software-defined architecture, we can do that today without relying on these DCNs. Okay. But what this beta program is to get some of this DCN hardware in your hands for labs. Now, one of the things you'll have to do, obviously, is commit to give us feedback, and so that we can understand how we can improve on the device and on the application itself. So scan that, and there's some out in the front too, so you can continue to get that. The other thing I wanted to leave you with, oh, look at that, 6 minutes. The other thing I want to leave you with is one of the things that came up last year was really, and Dave, thanks very much, actually, because, prior to last year, we hadn't been having a ton of events. Obviously, COVID, travel was difficult. We all figured out this new way to have meetings called Teams and Zoom and everything else. And so we thought that was kind of the future. But you realize that when you come to an event like this, there's so much more than actual content that's actually shared. It's the community, it's the conversations that you have, it's the meals that you share. So, Dave, thanks very much. I think last year for kind of indulging everyone and facilitating having the first one that we had in the last year. But one of the things that came out was that it was, and I asked this question last year, was how do you get information today? Right? How do you go about? And I will, by the way, make these slides available. So we'll, you know, all of this information will be shared. I don't, Dave will figure out where we put these slides for you guys. So you'll have all of this. But a couple things. So the Schneider Electric YouTube channel, right? So there's a couple things there. One is obviously some of the videos that I shared today, all that kind of stuff is there. But the other thing that's there, especially for EcoStruxure Automation Expert and our next generation technologies, is a lot of how-to videos. So if I get a soft controller and I want to load it on my, how do I load this on here? How do I start it? How do I build an application? How do I do all of those types of things? All of those types of videos are on our YouTube channel. The DCS webpage. So this is where we're kind of keeping, it's changed. So if you haven't been to the Schneider Electric Foxboro site in a while, it's kind of morphing, right? We're trying to find, and actually if you have any feedback on that, we'd appreciate it. How you interface with the website. We're learning, right? So I'll leave it at that. There is an ongoing process of as part of becoming part of Schneider Electric is how do you fit into this very large organization? And if you just go to se.com and try to find your way to Foxboro, let me know how that works. Because I have trouble doing that sometimes. So just any feedback is good. The other is the blog site. Obviously, we have Just Ask the Expert newsletters. And something else I wanted to bring up, and this actually I think is a good point that I'll leave on because I want to make sure that everybody's clear. And you know, I know Dave mentioned it earlier, and one of the things that we do, we want to encourage you guys to continue having user events, right? And Dave rightly pointed out that this is for you, by you, with the content that you're asking for. Schneider Electric, there are other events that we call innovation events, right? There are innovation days, and there are innovation summits. So when we have innovation days, this is for innovation days for Foxboro, innovation days for any of the product lines. There's really a showcase, right? So it's like what Thad went through, but on steroids. It's come see all of our new stuff. Come see what Schneider is doing in Foxboro or what Schneider's doing in safety. Okay. Innovation Summit is that at the next level, which is what is Schneider Electric doing? How, and if you know anything about Schneider Electric, I mean, we're everywhere from the World Economic Forum all the way down to a small, tiny plant in the middle of nowhere, US, right? It is all of that, right? It is, where's our sustainability consulting business? Where's our power business? Where's our automation business? Where's our cybersecurity consulting business? Where are all of these bigger things? And so if you want to get an idea of, I just kind of touched on EcoStruxure and touched on some of the things that we're doing from an automation perspective. But if you really want to see what Schneider is doing, Innovation Summit is that thing, right? So that is the bigger thing. That's in Orlando. There again, that's not the deep dive technical. That's the 30,000 foot. How is all of this stuff? So we will have a huge area to walk through where you see all of these different technologies, and you'll see EcoStruxure Automation Expert running on all different types of devices. So if you want to kind of see what that future looks like and where we are in our development with that, that's a great place to go. I think, yeah, that's my last slide, so I'll go back to that. And with that, any questions, right? I know we still have some time. So any questions on next gen or kind of where Foxboro's going or EcoStruxure Automation Expert? Yes, sir. Okay.
That is like the root of the communication between all the different devices.
Yeah, you're talking about this one? That OPCUA? So he's asking about OPCUA and kind of that it's showing the OPCUA is kind of the root of everything. So this particular architecture is the OPAF architecture. One of the things that OPAF is doing is we're trying to make sure, and I'm part as well, we're trying to make sure that we're using standards-based technology so we don't end up in another place where you guys get reliant on one specific vendor proprietary technology. So OPCUA is a series of standards that does that. This OPCUA here is actually referring to OPCUA TSN, so time-sensitive networking. Okay. And OPCUA time-sensitive networking is part of the OPAP communication framework, which is OCF. So now I'm going to throw a lot of acronyms at you, but OCF is what OPAP considers their control network. And it's based on OPCUA time-sensitive network. I don't know, Dave, if you're going to.
But the people's experience with OPC, the whole OPC,
DM?
DA, and OPCUA, it's a whole different animal.
Yeah, there's a bunch of different OPCUA standards, and this is not the same. I mean, and there again, I think we're actually, some of the stuff is getting demoed now. Hello? Okay. No, but some of the stuff is getting demoed, and we're doing a plug fest for OPAF, where we're demonstrating some of these different technologies and looking at some of that. So I don't know if during your section, if you're going to promote or any of that. Any other questions, comments? Yeah. Mhm.
And this is like worldwide, but somebody logs in from Indonesia or whatever, and they want to serve the picture. Now you move all the switch to whatever switch the company inside.
Okay.
Also, hardware like dependency on servers like HP, UAVs, and all that. It's a big push to move to whatever they want, as long as complies with the requirements of the hardware.
Okay, so I'll repeat that for those of you who didn't hear. So he was just making the statement that so there is a push now for IT organizations to kind of start to say manage the switches even globally, so to be able to pick whatever switch the company wants to pick. Same with the workstation and server hardware, that they want to be able to use their supply chain just like we all do to get the best deal and to get whatever, as long as it meets the minimum requirement. And I'll say that in the future, that's actually where this next generation system allows you to go, but doesn't require you to go. And now let me explain that, because even today with the Foxboro system, we offer things that we call engineered solutions, right? So to your point, if a customer says, well, I want to use a Lenovo workstation, I don't want to use Dell or HP, or I want to use a Stratus server, you can, right? You can, but it becomes an engineered solution. And the important part of why we designate an engineered solution is because we want to make sure that the local service community and the local delivery organizations can actually help support you with that decision that you've made, because we haven't gone back and actually made it a product that you can buy in bioautomation. It's either because it's a local type or because of the volumes that we're looking at. The other piece of that becomes the long-term supportability. So there again, if your IT organization says, well, we're going to support it, we're going to use our supply chain to manage the life cycle, and we're going to get the best deals and we're going to get it, that needs to be an agreement. But the final point, and this is where it becomes really important, and this is why I mentioned, if you want to stay with Schneider Electric, when you choose to stay with Schneider Electric, we'll have a reference architecture that will be the next generation Foxboro DCS, where we will have selected workstations and switches and software and hardware, so our DCN controllers, that we can actually go through and do that whole cybersecurity compliance too. So before, if any of you have ever done any kind of compliance work, you know that you always have to submit some sort of reference design, some sort of reference architecture, some sort of reference cabinet, right? So we'll have a next generation Foxboro reference architecture based on these types of technologies, with switches that we recommend and we support, with workstations and servers we recommend and we support. But now you'll no longer be bound to that, because we're actually telling you that this next generation of system and actually is developed to be multi-vendor. One of the things that OPAP will introduce, and this is kind of where we all start kind of to merge, is this concept of a super systems integrator. So a systems integrator of systems integrators, if you will. So today we all act like systems integrators of our own proprietary systems. So our delivery organization is effectively, in OPAF terminology, a systems integrator for Foxboro DCS. Super systems integrator would be that integrator that provides you the integration of all of those different systems. So say a Foxboro with another vendor system, with a third vendor system, that overall system. So an OPAF solution, like I even just showed you now, would allow you to build technologies that are using multi-vendors, and you would rely on that super systems integrator for development. There's also a new category of support. So they don't imply that future service organizations and future support organizations are still the systems integrator. They actually break those out into 3 different pieces so that you could say have a systems integrator and have a completely separate service provider, right? Or a completely different maintenance provider. So these are ideas there. Again, I think this is in the business plan, the first document of OPAF. If you're interested in it, I don't know if we talk about that. If not, I can bring it up here later. But they kind of talks about all these designated roles, but the intent there again is to allow you to actually have an architecture like you're describing. So I think in response to your comment, the answer will be yes, depending on if your company is prepared to provide that level of support to you as OT owners to say, we're going to stand up, and it's happening today. You're exactly right. I mean, I have a lot of end user customers who we're going to have one domain, right? We have multiple automation vendors. We're going to have one domain. We just need your group policy objects and your users, right? We're going to stand up one domain. We'll manage it. We'll test it. Okay. It's absolutely fine, right? But there again, that becomes a service challenge, which is why we designate that as an engineered solution, right? Any other questions? Comments? All right. That was easy. Thank you very much. I will, as I said, I'll make these slides available to you all. And who's up next, Dave? Thank you.
Yeah. So it's just create a system sound just comes in there.
So they choose me to talk to you about HMI. I don't know if it's good news or not, but let's try. So my name is Kader Ashur. I grew up in Egypt and I moved to US 2008. Many of you know me. Um, I live in Houston and I like warm weather. So this is very cold for me here now. And I like cycling. So anybody who likes cycling can ask me questions about cycling, not HMI. We will talk about HMI. And the main idea here is to share with you what can we do better, or how can we make the best use of our upgrade of an HMI. So the idea here is not just conversion. I keep receiving the question about, okay, do you have a conversion tool to convert my graphics? And my very first question to you, do you like your graphics? If the answer is yes, so why do you want to convert it? Just because we said FoxView is going away, that's not a good answer. So the main idea here is to make sure you benefit from the conversion. You benefit from the investment, right? You are going to invest money into your graphics. So you want to make sure you benefit out of it. So in order to do a proper foundation or path for your HMI upgrade, you need to be able to identify some key elements. And we will discuss in the first half here the key elements you need to consider. Ask yourself internally, have the discussion internally. I know I spoke to a few of you in the last day or two. They already started to have the discussion internally with operations and making sure what do you have good and bad and start investing there. So the very first thing, why would you go after an upgrade? Why would you try to upgrade your graphics? And I picked a couple of typical common motivations like mitigate obsolescence. We have been talking the last couple of sessions about obsolescence of your system. Guess what? HMI also goes into obsolescence because it's a software, it's an application. And what has been built over the years, maintained over the years, like if someone has a plant that started in the late 80s or something, so most likely the way you have implemented or the way you have developed your graphics is no longer the way we develop graphics today. So you need to start looking at the obsolescence of that one as well. The product itself, the product was a file-based product, and I will show you a slide about that. So when you have a file-based product, now when we start to talk about connectivity, high availability, connecting to other vendors, connecting to other packages, the file-based is not really helping you. You will need something else. We call it system platform. The operational efficiency is all about the situational awareness part or has high performance part. And basically here, the operator is very capable because he spends most of his time in front of the HMI and in front of his devices and assigned responsibilities. So he knows very well, but he has been over the years accommodating deficiencies into the application. Like you will find an operator click, he knows very well, I need to click 7 times to get to this specific element. 7 times is a deficiency. Then he complains about call-up time. Yes, because you have to navigate 7 times to get to this element. That means you are not using your application properly, and that's a deficiency. So we want to help the operator to satisfy his duties, his responsibilities. How can we do that? We need to listen and understand how he functionally has to fulfill his responsibilities. What does this mean? We need to translate what he has to do every day on the graphics. That's exactly what has to happen. Now, the inconsistency, which whenever I used to visit a plant, you will know right away. And I know very well you know what I'm talking about. You will call the first graphic, it's high performance or grayscale. You call the next graphics, it's a Christmas tree. So how can you bring one operator, same plant, and have the same response to different input? And guess what? With the current like moving resources around the universe and having people operate remotely and manually and stuff like that, how can you maintain consistency? Guess what? You can bring one operator who is a power operator and tell him you need to start this chemical plant, and the colors are opposite. So what can you do? there will be a trip the next moment, right? Risk identification. So basically, a wrong decision or a wrong evaluation is a risk by itself. So, and this goes back to the previous point of consistency. We want to be sure the graphics are consistent and it delivers the same message. Okay. And the technology availability, and the fact that we have new available technology in the market. And guess what? We are not using it in our industry as we expect. I'm glad you mentioned that the AI has been highly used outside our industry the last couple of years. Guess what? We are not using it. And that's not because we are deficient. We are capable. We do that at home. All my home is powered on and on lights and managed by AI equipment. But when it comes to an operator console, we use a file-based product. That's what we do. So we need to get ready for the transformation. And we cannot just shut down a system that's today file-based product and turn it on the next day fully capable technology, digital technology. We cannot do that. There is a path. We have to walk the path. We cannot jump the path. Okay? How can we do that? So moving forward, okay, we identify the deficiencies. We have to list down. We literally have to sit down and list where we are today and where we want to be. Then we start to find out how can we achieve that. Identify the opportunity, and if we have budget, what budget we have. Selling this kind of upgrades or investment to your management is not easy. Why? Because the plant is running, the operator is capable to run the plant successfully. And I keep saying that whenever I do workshop, I walk into the plant, I tell Mr. Operator, you know what? You know the plant better than I do. And I walk in, you are producing successfully. If you kick me out now, you still produce successfully. So I'm not adding anything to you. The actual value, we can help improve how he is operating. In other words, the feedback process, which comes to the operator through HMI, will be done effectively. And that's the word high performance and situational awareness. This is what it means. So that takes us to the return of investment. How can we make the case to get sponsorship for our project? It's not easy. And the reason for that, because whenever you speak to an operator, he will identify more deficiencies into the field that he wants to sponsor than deficiencies on the HMI. So first of all, you need to figure out if we can identify return of investment after we set the foundation with an operator. So you need to set the foundation first, make sure you understand. Yes, when you stand up and walk through the console and go to an external device, corporate, figure out through an email what you have to achieve, then walk backwards to your console and plug in what you read. And oh, what was that? And you walk back again, pick it again, and go back. That's a deficiency. That's definitely a deficiency. And I saw that. That story I saw myself. Okay. When you find an operator calling up, I gave that example last night, calling up 6 different overlays because he has to fire up temperature beds 0.5 degree at the same time. I told him why. I can give you one command. Whenever you want to fire up all the temperature beds 0.5 degrees, you just click it and it will fire up all the temperature. He said, yeah, can the system do that? Yes. Yes, computers can do anything you tell it to do. Just, you need to say it. So the idea is to get the operator to say it. And as soon as the operator tells us what he wants to achieve, we can program that for him. And that's not considered a custom application. That's actually an application. Custom application means I will write an application that will do something customized only for a specific operator. But if I am writing an application that will do his responsibility, that's not custom application, that's an application. That's a solution, okay? Any questions so far? Okay, so in order to achieve high performance or situational awareness, there are different angles. And if you look at the from different angles, you need to achieve it. Hello? Once you get to achieve these, so for example, it complements each other. If you start working on the alarm rationalization, which I believe a lot of our clients already took care of that part, which is very important because you have KPIs you have to achieve. That complies or that complements with the HMI. So if you have your alarm rationalization done properly, then your HMI will be effective because guess what? HMI will rely on what you have done on alarm rationalization. The main idea here between the level 1 and the current alarm display or alarm provider or whatever you call it, but the alarm display, between these two pictures, you are covering 100% of the day-to-day responsibility. Does this mean I copy every single element on my level 1 display? I hope not. That answer is wrong. We want to be able to find an abnormal case received as soon it happens based on the responsibility of the operator. So if the operator is responsible for shipping, I need to receive an alarm from shipping. If it's not part of his console operation, then no, it doesn't belong to him. So it's functional. What does this mean? It means I also alarms, graphics, and the console itself, the layout, okay, the communication, the operator loading, that all is part of the story. So if I have poor communication, I was working one design and they had 3 different locations. They decided to go the next step, remote operations. They were successful almost to 90% in my opinion. The only thing I noticed was a deficiency was like, okay, you are moving forward from a local operation to a remote operation. And there will be a local operator for manual effort available. Good. How are they going to communicate to each other? Because first of all, the local operator used to be operating from the console before. Now he's not. Now a remote operator is operating in a central location. But when the local operator went to do an action, he will walk to the field while the other operator is doing something. So they need to communicate. Otherwise, you will have an incident. So operator loading and operator communication will complement the entire picture. Depends on your goals. So you need to start evaluating where you want to be, how you want to achieve. Is it centralized control, like central control room, or distributed control rooms? And each one has its own applications, okay? We did one application one time. There was a no-man in the offshore. So they bought a hardwire button that when you change the button to enter the room, it will take all the controls from local to remote. And this way we were able to confirm that you are controlling remotely only or local. And that was a successful application because it goes back to you need to translate how you want to achieve your controls. So far, so good? So in order to do that, that's what you need to achieve, to do a gap analysis. So you need to start from what philosophy and standards, compare it to what you have today, and provide a list of improvements. That's how you do the gap, or figure out how big is the gap, and then start a development plan. It doesn't have to be all the way at once. You can schedule it into a tier approach until you are there. You just set a plan. It's 2 years, 3 years, 4 years, 5 years. We have a 5 years plan coming. We will talk about it today. So you don't have to jump the way. You need to walk your change. That's the idea. These are some references for standards you can use for your background. I'm pretty sure you know a lot of the standards in the market. Some of them are not enforced yet. Some of them becoming enforced. I'm positive in the near future you will find like cybersecurity now. You will find the insurance companies like you need to be in compliance with this cybersecurity. Otherwise, we cannot give you the insurance you need. Same idea. Alarm management is enforced somehow now through corporates into your KPIs. Same deal. The HMI is coming soon. So be prepared for that. Yes, a lot of our operations don't like the word grayscale, and we will cover that part. I know it's a struggle. It's a battle you have to go through. A lot of operators don't like the light in the control room, and they like it dark. But you know, we will have to cross that bridge somehow. There is a trade-off. There is some kind of balance we can do, but we all agree that dark control room doesn't work. But only us, you know. When you go to an operator who's sitting in the control room, he has a point. He doesn't like, because it's very dark screen, he doesn't like the control room light to be like high contrast, so it actually hurts his eyes. So we have to work this out. It goes back to the design we have to achieve. So these are the reference, as I said, of what we have to go through. And in order to do the HMI philosophy, there are steps you have to follow. You go through the design process, control room attributes, large screen design, requirements for hardwired panels, and the style guide and toolkit. So guess what? The first step you have to work on, or at least have the discussion internally. Any thoughts? How about the style guide? You need to define your style guide. And once you define your style guide, you can go through the design process. What's the design process? So the design process, and I have a slide about that. You go through the training workshop. The training workshop is basically setting the foundation. And we answer 2 questions. Why we are doing it and how we are doing it. So once you answer the question to the operator, why, and you need what kind of operators you need to join that training. Just the junior operators, so you don't have a lot of challenges, fights. As a matter of fact, you need a combination of both. You need a senior operator, experienced operator, as well as a junior operator. So you can get the mix of the knowledge in your workshop. You set the foundation first. You make sure they understand what you're talking about and why you are making this investment. Then you go through the model. Then you go through the knowledge capture, which is basically you start to ask the questions about how you operate. And the operator will be answering you, okay, from experience, I know when it gets to 67 PSI, I need to pay attention to this equipment. That's experience. It's not on the graphics. The only thing we do now, we use the tools to translate his experience on the graphics. Guess what just happened? You reduce the training for the new operator from 5 years on the board with a lot of yelling, a lot of phone calls, to a year or 2 years. Just by bringing the experience of a senior operator to the display. This way you are able to just tell the new operator, whenever you see that icon on the display, that's the action you do. So you translated it graphically now, visual, instead of telling him the story and learning by try and error to an extent that you will find graphic, oh, this object was developed 1991 when so-and-so screwed up. And this object was added 2002 when we had this incident. That's not graphics. That's just logging your history. But the reality is you need to control your displays. Then you go into prototypes, and that's one thing we miss all the time when we develop graphics. You just send us beyond IDs. We will get some of the smart guys. They will push it back to you, the same exact look and feel. We will meet for FAT. The last day of FAT will be for operators. They will do whatever they can do in 8 hours, including lunch and including chat talks. And then we handshake, we deliver. Then the operator will be living for 40 years or 20 years trying to accommodate the deficiencies because the testing was not done the same way it should be. So the idea here is we actually do a cloud-based implementation. You will go through at least 2 or 3 iterations of review before formalities. So we really, when we meet for FAT, it's really for formalities and just enjoying lunch. So that's the idea. Then once we deliver to you, you need to schedule every 6 months or something, a periodic meeting to go over your design deficiencies and clean it up. So over the time, you will get a better and better version of graphics. Second part is to go through the control room. Do you need to invest high? Maybe. But the idea here, most of the vendors in the market now, they can give you a 3D rendering of your new control room before you spend the penny. Make use of that. Every vendor, almost every vendor in the market. If he says no, then go to another vendor. Just don't worry. Most of the vendors will give you a 3D rendering. You give him a layout, you give him dimensions, tell him your goals. They will give you the 3D rendering of your control room. Use that. It's like you are redoing your home. You are ready to spend the money already. Have them show you what you can do before you do it. Then have internal discussions, validate your console layout and control room layout. Then tell him, okay, how much this will cost me, and you go find the budget for it. But at least there will be no surprises when it comes to implementation. Then the large screens, selecting the large screens, and that's typical argument with operations, because operations always want 200 monitors, 300 monitors. What is the right answer for that? The right answer is we need to translate functionally. The more monitors sometimes is a good answer, but sometimes not. So you need to answer what's your function, what you are trying to show on this specific display before we purchase this display. Not just, you will find one of the arguments, one of the operators was telling me, I need to be able to repeat these graphics so and so many times. I'm like, okay, why? He said, because I don't want to go there and call it again. Fine. But why you go there and call it again? That's a deficiency, because you are trying to call the display many times in front of him, and you find the console actually 2 or 3 graphics repeated on 12 monitors. Why do I do that? So you need to ask functional. Go back to functional, okay? So this is how the process looks like here, graphically. It's basically what I just described. Go through the workshop, then the execution model, knowledge capture, then design. So far, so good. Any question? And then you need to also evaluate the hardwired panel, the alarm annunciation. Anybody still using alarm annunciators at their plants? And alarm annunciators? So is it functional? Is it still working? That's good. So when you go through the design of your new control room, you need to figure out where does this alarm annunciator will be part of the entire design. It shouldn't be the last thing. Oh, let's figure out where we put the keyboard. Oh, there is no spot for the keyboard and the annunciator. So again, the vendors will help you set this out. Then the toolkit library. Most of the vendors in the market, including us, we have a standard toolkit available to you. You can use it out of the box as is, or develop your own version of it. You start from the standard library, make little tweaks, and then call it your own library. Is this considered custom? Yes or no? Who thinks it's considered custom if you take the standard library and make your own version? It's custom? It's actually not custom because it's an orchestra object. So you can use it over and over and over again. So you just come up with a style guide, apply it to the standard one that comes out of the box. The one that comes out of the box is actually a version that applies to all. We cannot make a version that works exactly the way you are running, because basically we are trying to satisfy all the market needs. But you will define, for example, I have red and green. I hope not, but I have red and green for on and off. The standard library says white and gray. Or you can say, is customization? No, this is not customization. This is just selecting what works for you more based on your style guide. The customization is when you say, I need the object to be connected to a specific tower, specific way, and functional special overlay. This is custom. But if you change the parameters, the standard parameters we give you to change, it's actually designed to be changed. Not like FoxView. FoxView of the old days, if you want a valve to look this way, this way, this way, this way, that was 4 different files. No. We give you an option to select which direction the valve will look at. And that's a drop menu. So you just change the drop menu, and you are not changing the library. You are using the features we are providing you. See the difference? Little bit. I can show you pictures of that. So these are some samples of questions that you can start asking yourself and internally. Do I need lots of trends or fewer trends? Do I need red and green or not? What's the font size? The bigger the font is better? The answer is depends on what screen resolution and how far you are from the screen. So there are a lot of questions you need to ask yourself. And I will make these slides also available for you for reference. Who might be challenging you? Is it internal operations or no sponsorship, or you cannot touch the displays, or no shutdown? By the way, HMI changes are never on the critical path. Database, you need a shutdown. Like when you do, if you have the latest CPE, you don't need to shut down because it's an online upgrade. But if you have to shut down, it's only for database. And there is no way you want to do a database change and the HMI at the same time. I wouldn't encourage that. Make one change only at a time. That's for your MOC. Any questions? Correct. So the question about color codes and using what works for different levels of experience. The standard in the book says you need the 3-way coded change. So it's text, color, and shape. If you implement these 3, then you are able to eliminate some of the color challenges. Yeah, but you also want to be consistent. And consistent means if I use red for critical alarm, I don't want to use red for a standard stop indication. Because the idea is when I scan through my graphics, my eyes need to be uncomfortable to see red. If I start to be comfortable scanning through and red is okay, you will miss one day the red that's not okay. And that's the idea. Now we go to the challenge. No, it's better to stay away from the colors that are well defined for an alarm. If the color means something, you just need to be consistent using that color across. Stay away from alarms. But if, for example, I was creating one library and they had brown mean manual. So they said we still need to keep brown as manual. And I said, why do you need to see the brown as manual? The answer was, we scan through them and we want to make sure nothing is left in manual. That's actually the definition of abnormal situation. So that's not Christmas tree. That's the exact definition of abnormal situation. You are scanning through them. If you find the brown, you will turn it back into auto. So that falls under the book. The book doesn't say that. The book tells you need to be consistent and you want to make sure you are not using salient color for alarms, and you want to make sure you are consistent. That's the idea. So as long as you have a definition, a meaning, and it has been a good practice over the years, they scan through, if they find brown, you turn that valve back into auto. That's actually a good practice. We don't want to take that practice off. We are making it better, not worse, Did that answer your question? Any other questions? It's very cold here, by the way. So when you do the design, you need to focus on the detection and diagnose and recovery. And what does this mean? When I walk into the plant, I'm an operator. I'm going to meet my previous operator or the operator before me. I should be able to, within less than a minute, I should be able to tell I'm going to have a good day or not. If you are having a shift change that takes half an hour, yes, good to talk to each other, tell him what exactly you did, but you need in the first 30 seconds or 60 seconds, figure out I'm going to have a good day or not. If you have that, then you have a good level 1 display. It tells you a full story right away, what you need to worry about. Does this mean you already went through every element? No. You just want to know, did I cover my responsibilities or not? You got the idea? So the detection process is exactly when, and we have examples of that we can share together. The detection process, when an abnormal case happens, we are going to work on reducing the detection time. That usually takes longer time. So we want to make sure the operator is aware, and that's the word awareness, aware of the abnormal case when it happens. If this takes longer, then the operator has shorter time to recover from the abnormal case. If this takes shorter, then the operator has longer time to recover. So if we have a typical operator that's going by alarms, does this considered longer time or shorter time to detect? Longer, because you already took the time. You are in alarm already. Everyone in the plant, not just the operator, knows about the problem. So you need to help the operator visually to pick up or find about the change. Trends are a very good tool, by the way, for that. So when operators are telling me when I walk into a plant and they have trend pages in front of them and they are scanning for irregularity or abnormality, that's actually a good practice. They just scan for uniform trends, and whenever the trends start peaking up, they will see that right away. The same idea applies. So we want to make sure the detection time goes shorter. Then we increase the time for diagnosis and recovery. So once you detect the problem, operators are very good at the second part. It's actually us who need to help them with the detection part so they can do their work. And that's the improvement that we have to provide them. So far, so good? Did I lose you? Did you lose me? Okay. The simple selection, that's an idea or just a sample of a case from the market. Blind spot. Someone decided blind spot is unsafe. It can cause accident. So we decided, okay, let's figure out how to take care of that. One of the solutions, add more mirrors. Okay. Add more mirrors. But that solution is actually analog. He's trying to show me exactly the person sitting in the next car, how far, and so on. So the idea is, do I really need that or not? It depends on the application. Do you need while driving to know exactly who is driving next to you? Not really. So one of the solutions that has been, not this one, but one of the solutions that has been successful is actually the digital indication. Does this mean you go digital all the way? No. But in our case here, it works. Then technology came into the picture. They added a camera. Cameras are cheap now. They added a camera, and now I was surprised a few days ago. My slide, by the way, used to be before this slide. I added this because I was literally distracted sitting next to a guy and this thing jumped in front of me. There is a car next to me. And I said, that's not using the technology right. Because now we go back to fancy. All I need to know, there is a car on my blind spot or not. That was distracting. I didn't like it. So it goes back to the function. What do I have to do as a driver? I need to know if there is a car on my blind spot or not. If you are able to answer this question, task is done. We are good to go. You can do that analog as I showed you, or you can do that digital. But at least you need to answer the question. So far, so good? Grayscale. So we said we need to be consistent and non-salient. And the idea is to you scan through your graphics, nothing jumps at you. That's the main idea. You don't want, in a good day, something jumping at you. You only want things to start jumping at you in a bad day. The standards are saying, go all the way gray. When I talk to operators like that, they keep yelling at me. I had bad days, guys. Seriously, I got people yelling at me for non-stop for like 2 hours. Then we found a common ground. So, for example, the standard says, don't go red and green, just go white and gray. But we found we can do that. We can do gray and green. Not that shade of green. That was limitation on my paintbrush tools, but try to do non-salient shade of green. Now, the operator used for green means go. I'm not talking to the power guide now. So green means good to go, okay? And red means stop. The only change we will introduce here, gray means stop. Why gray? Gray means it belongs to, it's in the background. It's part of the background of the display, okay? So it means stop. It's in the background, while green means running. So this way you still have some colors, which operators are very keen of, especially for the change, but you are not breaking the consistency. You want to make sure everything is consistent. Good idea? Questions? I go quickly through this so I will get a chance to interview with Bart. So the idea is to make sure you have non-salient the object when it's in alarm, it jumps out of the screen to you, like the picture you see in front of you here. Detailed operator, detailed duties. So you are trying, we spoke about that, 80% level 2, 100% between level 1, 80% level 2 actions, 100% level 1 and alarm display. So if, for example, we have a detailed display like that, if we just turn it like this in grayscale, that's not good. We did not achieve the function this way. We just made it boring. That's why operators hate us. Literally, I'm not joking. This is why they hate us. You took this from me and you give me that? No. And if I'm an operator, I would say no to, because this is really bad. Okay? So it became an overload. Instead of things where, at least in color context, it became an overload to an operator. He definitely will hate me. Then we start to introduce visual shapes. That's the idea. And that's why you need advanced application to help you. So the idea here is actually to monitor for irregular shapes. You monitor for trends across. Does this mean we took off the numbers completely? No, the numbers are still available with a button. You can click the button and it will show the numbers for you if you care about the numbers. But the idea is to make sure I can monitor the temperatures across beds and through all beds. That's the idea. I want to make sure I see that visually. So in a bad day or something, you will start to see that the slope changes. And that's the main idea. When you care about seeing the individual number, we can show and hide the numbers for exact details, or click in on the tower itself, and the level 4 will bob up and it will show the exact numbers. But for scanning through operations, you need to scan through shapes at the beginning. Okay? World is not that ideal, but we can work out something. Control HMI versus FoxView. Who thinks FoxView is better? I was surprised. Maybe I was going to why you like FoxView. And I have been there until I hired one of our coworkers, and after a couple of years I told him, if you prefer to join a project or like work on a project, what would you go, Control HMI or FoxView? And he said, Control HMI all the way. I said, that's an interesting answer, because if you ask any one of us who are like 20 plus years with the company, we will say FoxView. And they said, but I can do a lot of stuff more in Control HMI rather than FoxView. So it depends what you are comfortable with. It depends. You have your tools, you have your scripts. I was telling an example yesterday, I literally built an entire project on my airplane because the entire project, I forgot it at home. So I built it again on my way to the client on the airplane, one time. So it's easy. We have tools, we can do things. Control HMI, because it came into the market, we didn't have tools since 2014. Lately, there are tools. So things are getting better. So over the time, you will find more support, more scripts, more bulk generation object and things like that. That will help you. And you can bulk edit and stuff like that with what we used to do in FoxView. But if we are talking product to product comparison, the biggest difference here is actually Galaxy integration versus file-based product. This is SQL-based product versus file-based product. So integration to other objects, integration to EAE, integration to other platforms, integration to Allen Bradley, integration to Triconics will happen only here. You have to custom. This is highly custom in FoxView, in file-based product. But when you convert a FoxView product to Control HMI and you insist to make Control HMI another FoxView, that's failure. I promise you, you will see the ugly side of Control HMI if you try to make Control HMI another FoxView. So use Control HMI with each feature and go back to the functionality, go back to the functions. I am trying to do this function. Let me see what Control HMI or how Control HMI does it, and then implement it with Control HMI way. If you try to write it the same exact way, file-based, and do external sources, have your scripts, go grab the data from files and bring it, Control HMI doesn't need that. Control HMI, the system is based on system platform. It's actually an orchestra object. You have everything sitting inside. Why would you go outside? Everything is already integrated into IDE. So use the capability of the system. So the alarms are actually almost equivalent. But when it comes to the security settings, you have everything embedded into Orchestra already, connected to your domain controller. You also have the roles and everything defined into the Galaxy, while you have to do that externally for FoxView. The device integration object, you can integrate almost all PLCs. Remember system platform, Wonderware? You can connect any PLC to it. So that's actually the platform we are using for Control HMI. And the situational awareness library that gets out of it. Centralized engineering. How many of you don't? Every project I migrated, I promise you, we didn't find which workstation has the master database, master FoxView. I graphics because they missed two operator actions. are actually logged into IDE, and system management console is available to you. So these are plain difference between the two products. You do not need to migrate FoxView just because we say it's end of life. That's what I want you to make sure you take out of this. You need to migrate it when you feel there are deficiencies today with your product. If you find yourself not able to make it, or your graphics are just on-off kind of graphics, like just on-off, Control HMI is not going to add to you. So if it's just on-off, just go back to your CSE and say, you know what, I'm staying with FoxView. You need to extend the limit, the support, that's it. Because there is no actual value on moving away from FoxView. You will just turn on-off boxes into another on-off boxes. That's not investment. You see what I'm saying? But if you start to integrate to other PLCs, other devices, EAE, and go to the future, then you need to move away from FoxView because FoxView is not going to help you. So far, so good? And this is the conversion. Again, I'm showing you the conversion just because I keep receiving the question a lot. I don't encourage you to do this blindly. Promise you will not do that. Converting what you have today and inheriting the same problems is not the right answer. Okay? And we have a validation tool, by the way, for anyone who doesn't know about that, because that was some of the concerns I received. Control HMI, the latest features, it's based on System Platform 23, and it's Windows Server 22, SQL 2019. And that's it's a new interface, new GUI. So it's not the same what we used to have. Everything is new now. Who has Control HMI so far? Anybody here with Control HMI? None? That's a good news. So, by the way, if one client I was going to appreciate and thank, because they have been so much patient and they did help us into making our product better. So we thank every client who has been in Control HMI. But the system was based on System Platform 2014. There are limitations with that system. The InTouch was a limitation. So that all goes away because, like for example, when they used to make changes, deploy graphics, they used to restart the entire application. Operators were not feeling good at all. Like suddenly, if I need to make a change, suddenly we have to reboot the application. And that was very challenging for operations. So they didn't like that at all. With the System Platform 23, you will deploy without a restart. For you, you don't care. Like you already FoxView, so you did not have to go through the pain. But I'm telling you, some guys who started 2014 had to go through the pain. Historian, we used to have real-time historian and the historic, the alarm DB, and the alarm is recorded or logged to the same database. So that's actually good news for existing clients and good news for you when you decide to move. Multiple trends, the trend application has been completely revised and have been done. So all the pain that customer reported and yelled at me personally many times was reported back to development as was taken care of. So we are in a better position. Any questions so far? I know I exceeded the time. Do I have like good to go 10 more minutes or 15? Okay. So today we have Bart Betty, and he is actually from Alabama River Silos, a process control lead. And we have exchanged a lot of discussion together, preparing for moving to situational awareness. Bart has invested a lot into his control room already. He has upgraded the control room, centralized control room. I was impressed when I walked into it. It's very modern, and it's a very good design. we were trying that he present all that today, but he said, I didn't finish my project. So at least he was generous enough to accept that we ask some questions that I receive typically from clients on projects, preparing and planning. And we want to ask the same questions to him and see someone who is not Schneider, Foxboro, not trying to sell you something, what he will say.
Our initials, the situational awareness graphics was in 29. The control room is about the size of this room. All the operators for the whole mill sit in the same room. They have 6 55-inch screens. They have sound cones, the circadian lighting. It's good technology. It's pretty nice, but we are missing the graphic side of it. So initially we struggled. 2019 we went to Houston. We sent them some of our graphics. They converted them for us. Then it was in the scope of we call it DOC, Daily Operations Center. It's not centralized control room. They wanted to make it special, so they called it DOC. I know I ain't got but a minute, but we went through all the common motivations of trying to justify this. We struggled with getting senior management to buy in on it. You know, they want ROI. Well, how can you justify new graphics with an ROI? So, operator effectiveness. That's what we're shooting for, and we're in the infancy of the project now. We have not had any of the workshops, but just working with Kadri and Scott Landry and Chris. So, if anybody's got any questions, I'll try to answer, but we're not very far along. So I can't speak to the success of it yet because we just getting started. But
I have prepared some questions based on what I received. So the first one is, when did you first consider taking actions to improve operator efficiency?
Well, that was 2019 when they decided they were going to build the Daily Operations Center, which is, you know, the centralized control room. We wanted to go that route. It was in the budget initially. We had quotes. We went to Houston, but ultimately senior management cut it. I guess we didn't justify it well enough back then, but we've got a head of steam now. We're moving forward. So looking forward to it.
And actually, like it went like when you came with the upgrade to virtualization, you found it's actually a good fit to through this.
Yeah. So we're also going virtual too, by the way. Well, our mill is, and Scott can correct me if I'm wrong, but we're around 16 servers, around 30 WPs, 25 plus CP pairs. So all going virtual.
So how about what challenges you were trying to resolve when you try pursuing this?
Well, the biggest challenge was getting commitment. You know, management says we've got graphics. We've been running on them for 20 plus years. Why do we need new graphics? So it's that whole justification piece for them, getting them to understand that you'll be improving the effectiveness of the operators and operator actions.
But what operations challenges?
What do you mean?
Like what deficiencies you found on the graphics and you were trying to...
Oh, that graphic you showed a while ago is very similar to what ours looks like, where you had the old graphic and the new graphic. That's what ours looks like. It's so much stuff on it. I don't see how operators honestly can operate on them. They're so busy. They're so color, and we're power standard, so that red, we're gonna have to figure out something to do with that. Well, I mean, we've got some. We don't have a lot. We have actually not done any of the graphics conversions yet. We have not had any of the workshops. The only converted graphics that we've had done is in 2019. We sent them 4 or 5 graphics, and they did a pseudo mock of what it would look like in control HMI versus
But it was pretty telling because I showed the leadership at the mill how many alarms does the operator have, and I showed them our old graphic, and they're like, I don't know, 8, 10, because you got all the red motors are red for running, valves are red for open. And then I showed them the control or the situational awareness graphics, and they were like, oh, he's got 2 alarms. I mean, you could tell right off the bat where the issues were, based off the absence of.
How you doing, John?
So at least you're paying attention. Wait, over here. Who's back there? I don't know. Come on. Don't be embarrassed. You put in, yeah, doing it. All right. The rest of you can go check emails for the next 30 minutes. How many of you that I got the PLC 5s installed those PLC 5s? Yeah, all right. Come on. Don't be embarrassed. I worked in the 90s too. 90, I was gonna say it's got to be like 90 to 99. Somebody probably knows when PLC 5s were obsolete. But it can't be much past 99. Yeah, I thought it was the Foxboro stuff. Well, Scott Landry and I both started in '89 and have 35 years in the company. You should have seen me somewhere doing a demonstration for you, because that's what my whole career has been, pretty much just doing demonstrations. Although I started with the training department, so I might have trained you on IA, which is what IA stands for, Intelligent Automation. Does everybody remember that? It's not industrial automation. Like, I see she's kind of like, no, it's not. That's not the right thing. Okay, so here's what I'm going to talk about for about the next 30 minutes, and Bud Miller's going to talk about some other options as well. How do you convert this PLC 5 to Foxboro DCS? Because, of course, if you have a PLC 5, you would like to move that to the Foxboro DCS. I mean, right, maybe I'm a little biased on that, but that's the idea. We want to do that without rewiring. That's the critical piece. The whole migration strategies of all Foxboro's migrations is you want to do it without rewiring. So Allen Bradley makes it real easy with these little swing arms that they have. And if I just pop this one off, this is the piece that's Allen Bradley that stays around. And I'll show you more pictures of that. So let me go through. This is a tested, validated, documented architecture, which is a Schneider Electric thing. And I'll go through this, and I've got some pictures, and then we can see if you have any questions. And of course, I've already set on the demo guy. So all this is set up on the demo floor, and we can show you how it works and how it looks and answer all your questions. So the first part of this whole thing, right, there's warnings, notices, warnings, cautions. I would have said, if you're stupid, don't use this product, and been done. Yes. This is the first part. So what you're going to do is you're going to go in and you're going to take the swing arms off with the wiring, let them lay them down, and then remove all the Allen Bradley stuff, the entire rack. You're going to put this rack in its place of where you had your Allen Bradley 1771 PLC 5s power supplies, right? So far, so good. You bolt it to the wall. We had to tell people that. You then mount one of these. See if I can stop dropping this. You take one of these guys that our buddies at Weidmuller created for us. This is the cable solution to go from the PLC 5. So you take this and you put this on the back plane. That's what's shown here. So that's just that thing right there. That's all that is. Pretty straightforward. Then you take the swing arm that's laying there with all the wires still intact, right? Put that on the bottom. So now you're looking at it like this. See, this is a dexterity test here. Okay, so now it's just like this. Guys in the back, you can't see me. It's okay. Then you close the front part of it. So see, this is the very back part. So there's two DIN rails. There's one in the back, one in the front. And there's two swing arms to this whole thing. This is the Allen Bradley swing arm. This whole thing is the swing arm that we talk about that moves the whole front piece back in place. The idea there, you then mount your compact 16 slot base plate, right? That's what you recognize as a compact base plate. And then you just plug in. Let me show it. Oh, because you got to screw it down, and then you plug the cable in. So then this is the cable right there. So that's all behind here now, and that just plugs in. I told you this wasn't rocket science, right? Didn't I say? I already say that. So that's all we're doing. We're making use of these swing arms that are easy to take off. Electronics. How many electronics are in 100 series nose cones? Come on. None, right? How about 200 series? Those quaint FBMs that can only handle 24 volts. So all the circuitry is done in the TAs. That's why when you go from 100 to 200 series, you have a TAA, because that's the electronics that you need to knock the 120 volts or whatever it is down to 24 volts, right? So here's great. This is ideal because there's nothing here. This is not going to break on you. These are just the swing arms. What Weidmuller put in here is they put in the electronics that we need here to go from 120 volts or even 24 volts. All right, more questions. An Allen Bradley PLC5s, I know some of you don't have these, but those who do, who powered the loop? Somebody said it over here. Field. Always field for discretes. So we looked at the diagrams, and you can say this is what you're going to copy, right? You're going to go. I don't need to show you a picture of that because I've already showed you that, right? But if you look at like one of these, we went and said, okay, you still have AC. Well, bring that in here. There's your AC low output device. We'll make that work. And that's obviously it's a 207s for your discretes in, 242s for discretes out. And then there's analogs. So I just covered the discretes pretty quick, but any circuitry that's needed, relays, solid state relays, whatever, that's put in this TA. Wonderful, right? All right, so on analogs, who supplies the power on analog ends? On Allen Bradley? Field. It's field. So on Foxboro FBM, who supplies the power then? It was Foxboro. It's your choice. What a great. And how do we do that? 3 terminals, right? All your 201s, 204s, 247, all your 3 terminals. How many you got here? I only got 2. It's got 2. I had to pick. So if you were going to do this is more questions for you. If you were going to do this, would you want to keep field power for your analog in, just you did 4 to 20s, or would you rather have the FBM power it? It's not a hard question. DCS. And that's exactly what we thought. So when we did the analog ends, we wired it so that you could remove the power supplies. So there is some wiring to change there. If you really didn't like that option, if you said, no, I'd like to keep those 30-year-old power supplies along with my 30-year-old stuff, you could still do that. And Weidmuller, well, they'll show you. They could make a cable that would do that. But we thought that one would be better to do it from the field. At least from the field, from the FBM. And that's why I figured we'd want to do that. So on the outputs, it's an easy question. Who powers outputs? Always the I/O card. I never quite realized that until I started doing some of this work. And like, yes, the outputs are always powered by the I/O card. So that was simple. That was easy to do. All right. So now I didn't talk about. Let's see. Like this is. Yeah, there's your analog. So for the 16 one, what FBM we do for 16 inputs? This is a better trick question. It's not that tricky. But if I had to do 16 analog ends, what Foxboro module would I have to use? 214 is good, but you're missing a letter. There's an E. There's a 214E. See? So the compact, we came out with Foxboro came out with 214E, which is 16 analog ends. So this one is being done this way, leaving existing power supplies. But you could change that and change it up. But go look. There's a 214E out there. Haven't seen it. Same ECB 201 as a 214, but there's a configuration change so it handles 16 inputs. So again, we had to look at these and decide what do we want to do. For the most part, we don't want you touching any wires, right? That's the whole key. Is you don't have to lift wires. So these were designed to be exact the same thing that Allen Bradley was using for the PLC5s. Well, Thad only gets one question. Thank you. I knew those things. I wasn't going to bounce. So all of these analogs were tested for heart. So in other words, we didn't just test the 4 to 20 milliamp signal all works and the channels all work, but they all were tested for heart pass-through and for field device expert in commissioning. And again, the demo guy, I'll show you that out there. I've got transmitters hooked up to the analogs so you can see what you would do. You can see why field device expert and intelligent commissioning is so cool. But that's not about this. But you can do that. You can move to heart. And I got to ask Mark, why would you want to move to heart? Anybody got any good answers? Yes. So first off, you're going to still control from your current. You're not giving up your 4 to 20 milliamp. Relax. It's okay. It's still there. You're going to control with it. But you're going to get PV, SV, TV, FV, and 200 status bits. And those 200 status bits could be telling you low air pressure on your positioner, right? And I can get that low air pressure signal over to my maintenance engineer, and because my operator doesn't care about that. But through Field Device Expert and Maintenance Response Center, we can move all those messages from all those devices. Not to mention I can configure and commission and maintenance and do diagnostics from the DCS console instead of going out to the field to do everything, right? So yes, these are all been qualified for heart. Like that was a good one. I'll give you a second one for the first good one. What else do I need to talk about here? Programming, right? You're gonna have to take your programs and convert those. So that's part of it. You're gonna have to take whatever you got in the PLC5 and you have to convert those to either, you can run ladders, you can do general device blocks, you can do calc blocks, you can do sequence blocks, right? So however you want to convert that over. So you still have to bring that all over, right, to get rid of that.
And the discrete FPMs, does the logic still reside in the discrete FPM?
Yes. So all we've done is created a way to get these terminals into the standard FBMs. So it's the same FBMs. So you configure them the same way you do all of them. Oh, and I didn't show that. I keep thinking there's a couple things. Got to keep asking questions so I don't forget stuff that I'm supposed to cover. So here, right here. Oh, can you guys see that? These are the modules that we did this for. Right? We didn't do not every one has been done. Although if you have an application and you want to buy them, or the wide miller guys, they will make them. Right? So there we go. I knew you were sitting over there. You're trying to throw me off. So yeah. So this is, you should recognize the 1771s, right? The IFEs and ODBs and all those. That's what they are for voltages. And then these are the swing arms from those. And then these are the FBMs we're going to do. So these are all compact FBMs because it was designed for that 16 slot. So some of you are going to go, well, I don't have a 16 slot PLC5. I only have a 4 slot. I don't have a whole cabinet to put it in. So they've also brought an example of doing this with 200 series FBMs where we can have a 4th position base plate. So it's much more narrow. So you got to look at both of those. You look at the big wide one at the big table, then the little one. So you can see there's lots of different ways to accomplish this. And of course, you could always rewire any one or two if there's one of these that's not being done. So you rewire a couple of FBMs. That's not such a big deal as opposed to this is going to cover the majority of what you have, or it should. All right, what else did I leave out? You've seen these. You've seen it's just a cable solution. It's pretty simple. You got to have at least one question. Yeah. So this big swing arm thing was designed to fit. So if you're in yeah, that's really what this is the same footprint as what is it, a 12, right? So that part has been figured out, and then the distance coming out, that's why it's packed in tight so that you can still fit it all in the cabinet. So it should be very close to the same footprint. But again, you could look at your cabinet and figure that out. So any kind of floor-mounted cabinet, you're not going to have an issue. But a wall-mounted cabinet, it depends how the depth, right? I don't know how much we calculated to figure out that's what the compacts don't stick out very far. And then these guys are tight behind there. But take a look at it and see. You can measure it. It's right out there. Then you know. But that's a good question. I should throw a lot of balls at you. Yes. So it was all done with compact I/O. thinking that we needed the space to fit in there. But what I've seen is we got whoever Cadre is, he's got customers that had the 4 position, and we're like, well, wait a minute, that maybe you can't fit a 16 base plate in there in that case. So yeah, there was a bunch of different ones. Yes, right. So you got to measure how wide those are and see if you can fit this one, then you're all set. And if you can't, inside a wall-mounted cabinet. Oh, okay. Yeah, so that would still fit then. You don't trust the wiring from 1991? Yeah. 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 Oh, and let's see. Where Christian wanted me to say something. Where'd he go? I think he's gone. Okay, I think if you're good, that's an easy solution. Get rid of those PLC 5s. Come into Foxboro.
Well, the solution is mainly aimed at addressing the hardware issue.
Yes. Yeah, I don't know that there's any conversions that you would do. It does. This TVDA talks about getting the programming from the Allen Bradley, but yeah, I don't know. Yeah, I mean, to me, I would just want to look at it and just recreate it because there's not, it's how much is in there. It depends what you're doing, right? I mean, it could be complicated, but it's probably not.
System started out life as drum timers, became PLC 5, so it ain't that complicated.
Yeah. That's what I kind of figured, but I don't. Yeah, so you got to look at it. Again, all these things. I say you all should take a look at them, right? Whether you're moving from an FDSI to an FDC 280, right? You should take a look at it and bring a TSC in to look at it and give you options and figure out where things are. And this is the same way because there's a couple different ways we can do this. And there's a couple that haven't been done, like the thermocouples and RTDs aren't done. We don't know how many others are there, right? So just creating the ones that customers have asked for.
You ever have to get back in behind there?
Yeah.
Do you have to shut down everything in the rack?
No.
At any point, or can you access everything individually?
So the way all your compact FBMs are sitting out here with the cables, you unscrew these 2 screws and you drop that down, and it's just going to hang down here facing that way, and now you can get to all of your termination assemblies. Like I said, come out and take a look at it. You'll see, but I don't have it hanging on the wall, which would be better, but it's on the table, so we can kind of take it apart and look at it. Okay, that was easy, right? All right, I'm going to give you guys some time. Do I need to yeah, come up next? Okay. You get to talk too. Yeah, take that off.
Good afternoon. You guys test. Can you hear me? So good afternoon. My name's Eric Castrucci. I'm the key account manager for Weidmuller, specifically for Schneider in the United States. For the Schneider team, I'm the point of contact for you. I cover from El Paso to Boston and everything in between. We have a team here together, but before I get to that, I wanted to offer grateful appreciation to Christian and Steve for inviting us, and for Christian bringing the opportunity to us originally almost a year and a half ago as we developed this partnership with Schneider. So look back there locally is Jeff Joyner. He's the district sales manager for the Southeast. So anybody that needs local connection, he's there. Senior industry solutions manager is Robert Crawford in the very back. Very knowledgeable. He's asking or answering questions in the back as well. Andrew Phillips, who'll do the presentation, is the PLC product manager for Weidmuller. And if you don't know anything about Weidmuller, we're a $1 billion organization globally. We're based out of Detmold, Germany, with U.S. headquarters in Richmond. We're going to focus on migration today, but also on our demo table is a pictorial of where else we play in the cabinet. Power supplies, terminal blocks, any number of things beyond migration. But today, the subject matter is migration. So thanks, guys. You'll get our contact information. And Andrew, it's all yours.
Hello. How we doing? All right. Let's just all stand up. Seriously, after lunch, you know. Yeah. All right. Sit back down. Um. All right. If you want to stand, that's good. So we can sit back down. My name is Andrew Phillips, and I'm the product manager for our PLC interface and migration solutions. And we've been working with the folks in Foxboro on this solution. But raise your hand if you have something other than PLC 5 that you want to get away from and go to Foxboro. Slick, Siemens, anything else? Okay, well, we can help you with that alongside our Schneider partners, and we'll show you about that here. Not clicking. A little bit more background on what we did. So this came to us actually. The PLC 5 to Foxborough project came through LinkedIn. So the power of LinkedIn. A couple years ago, they reached out to us to develop this solution, and it took a long time. So the project scope and list of requirements came from Foxborough. We modified our existing PLC 5 adapters, as Steve mentioned, and delivered prototypes for testing. They came back to us where we needed to do some modifications. And then we finalized on everything early last year, and Schneider tested and approved them in July. This list is a little bit different from Steve's, and it continues to grow as we look at new PLC 5 cards and how we can go to various FBMs. And the 16 slot adapter chassis is the biggest one, but we also have a 12, an 8, a 6, and a 4 slot to accommodate all those PLC 5s. So how we do this, right? The translations through the cable, the pin to pin. So we go through a detailed engineered drawing stage where we went back and forth with Schneider, and we tested in-house, and then they tested as well. We also go from the RTPs. So these are the Allen Bradley, call them termination blocks, where we cable from them to FBM 215. And you saw the TVDA. So we are delivering alongside them to a food end user in April. And then we're testing adapters for a specialty chemical end user this quarter. Anyone have any ABB? Okay. So we are in early stages of the SD, and we also have the S800, where we can go to Foxborough as well. Staying in the same footprint, not lifting any field wiring, a quick plug and play migration. Again, Weidmuller, we're on the hardware side, so we're not going to get into any of the programming. That falls on you and your SI partners or in-house, however you take care of that. So this is where we play. We want to go from them to green, right? Any of those look familiar up there? Okay, they're all old, obsolete, no longer supported. And we have adapters to fit any of those requirements. Any questions? So the S7300 ET200M is a new one for us that we are going to release this year. I believe they announced end of life, or Siemens announced 2025. So we have that ready to go. And here's a quick video, just kind of showing your traditional method of rip and replace, and the time consuming, the errors that you can encounter, and then how our plug and play solution fits. No, I don't. So you're removing all the field wiring, you remove your PLC, and then, you know, point by point, loop checking. Guy on the other end, hey, are you on? You seeing something? Traditional method. So with we call them MyBridge is our name for our adapters. With MyBridge, PCB that accepts the terminal block connector from the legacy system, and then a cable to Foxboro. That adapter chassis sits in the same footprint as your legacy system. So if it's slick, if it's you know, name your manufacturer, you're not re-drilling any holes. But depth is important to take into consideration. Do you have enough room to mount the new PLC on the front? Ah, yeah. German animation at its best. Okay. All right. Next. All right. So we're here to help. We're here to help Schneider. Yes. Yes. Yep. All right. Yes. Yep. We're after the past couple of years, our engineers have really, you know, with information from Mark Hunter and Steve, we've gotten documentation. We've really learned the Foxboro system. So our guys and their team are working collaboratively on. We have reoccurring meetings with them where we talk about it. So we're in lockstep with them. Anything else? All right. Thanks for your time.
Let's turn this off. I don't know how to turn this one off. Well, nobody's going to have any questions. I can tell that already. All right, we ready? This will be good. We'll get ahead of time. All right. Let me tell you guys about what's going on in a whole bunch of to my level, and then y'all will all feel very smart because you will be smarter than me. Okay, the first thing we got to know is, all right, let's see if my clicker works. Does my clicker work? Does not work. Hang on. Let's try this again. It is on, isn't it? Is there an on button for the clicker? There we go. Gotcha. Perfect. We're good to go. All right. So I've called this open versus open versus open, and that's going to be the thing. And spoiler alert, it's the wild, wild west out there on the open system thing. And you think of committees as being boring, and I get that, but who here has watched the movie Oppenheimer? You guys see Oppenheimer? Pretty good movie, right? It's nominated for 13 Oscars coming up this year. And it's a 3-hour movie. It's about a bomb built by a committee. These are committee meetings, okay? You watched a 3-hour movie about a committee meeting. Think about it. And you were like, man, that's exciting. So, yeah, I know. So it's pretty good. So, so I'm going to do kind of like the last guy had you stand up. I won't have you do that, but I'm going to have you think for a second. And what I did is for Galen, it's probably easier for you to stand up, Galen. So we do a thought experiment, and the first thing we did, because one of the things that we're going to take away from Mr. Martinez's presentation is he throws a lot of new words at us and stuff. And one of the things that we're having to learn as a group is we're going to have to speak a new language. Okay? This language is not our language. It's not the language we use. And it's now the good news is the guys that are over there using Honeywell products and the guys using Yokogawa products and the guys using Siemens products are all going to also have to learn to speak this same language. They're going to drag us into one language eventually, and it's coming. So we're starting to learn some of the new buzzwords, the new way of thinking, the new words. So that's what we're trying to do today, expose you to this and start thinking that way, okay? That's all I'm saying. So we're going to do a thought experiment. And so I went to artificial intelligence. I went to the Microsoft Copilot, used Dolly, and I said to it, visualize a black square. That's like all I ask. And if you guys all, I want you to just in your head for a second, same thing. Think of a black square, okay? I didn't say, just visualize a black square, all right? And this is what the AI engine came back with. Match pretty close to whatever you had in your head, roughly. Pretty close, right? I mean, even for me, I said, a black square, that's pretty close. That's a black square. Now we'll do the same thing, simple, a white square. And there's a reason. So it says, I want you to do the same thing. Visualize a white square. We saw what it did for a black square, so now we've got our frame of reference. We got something. So when we do that, kind of gives us an off-white square, but it's a square, it's white. We can live with that. Now, visualize something that's open. Same thing, same question. All right? And think about something that's open. Got it? That's what it came back with. Now there's a reason for this, because like, right, I got a black square, a white square, now something open. We're talking about these things, and the hard part is we've got words that what we think of, as soon as we get into a more abstract concept, how many people thought of a box when you thought of open? How many people thought of a door? I thought of a door. That was mine. I asked my wife, she said, I thought of a window. That's also, I was like, okay, I could get that if I just say, think of something that's open. Okay. So, but we're not used to, as we start talking about these things, we've got to all get our terminology straight so that we're all talking about the same thing. Okay. And so we're just throwing words around, and we're going to get everybody thinking the same way. So that's why I wanted to bring that up to start with. Okay. So I just thought, box, door, window, we got it. So your idea of open, my idea of open may not be the same. Well, the Open Process Forum
has an idea of open. And they define that with a stack of papers and stuff and books about 1.5 feet tall if you print them all out. And they tell you what open is. And unlike Oppenheimer, it's not near as exciting when you're in those committee meetings, I'll tell you. So we only have a few minutes to talk about it. So why would we want an open system to begin with? What technologies are out there? What should you be doing today thinking about the future? Not 6 months from now, not a year from now, but maybe 3 years from now. And it's maybe 3 years from now, maybe 5. Well, what are the benefits? Something that's interchangeable, interoperable, vendor neutral. There's a lot of reasons for that, right? When you go buy something that plugs into your wall, you do not go say, hey, you don't even think about it. You know it's going to fit. If you've got a 120 volt or 110 volt US standard outlet and you come in here and plug that in, it's going to be okay. You don't care if you get your power from TVA, who's here, or Minnesota Power, who's here, or Southern Company, who's here. All of it is the same. You just know it's going to work. You don't have to think about it. And that's what the Open Standards Committee is trying to do with controls. That's where they're going. That's not where we are in the control space, though. A Honeywell controller is not a Yokogawa controller, it's not a Rockwell controller. They're all different. So, Harry Forbes is a guy who writes for ARC. I meet him at some of these meetings. This is one of his from an article. I pulled this off the web. He says, and I'm just going to only read this one paragraph, a standardized automation system layer would be immensely valuable in economic terms. ARC research estimates the worldwide supplier DCS services market at $7 to $8 billion per year, and that end users spend approximately $20 to $30 billion per year to service the installed base. A substantial part of that spending could be avoided through a standardized automation layer. Far beyond the cost-saving standardization would enable highly skilled process engineers and technicians to focus more on production improvements than rewriting legacy code. Now, the first thing is the DCS market. In the world, we're spending 7 to 8 billion with a B a year. Now, that's like pretty good. It's a pretty sizable amount. But the more interesting thing is that we're spending 20 to 30 billion a year in servicing the installed base. That is 2.5 to 4.2 times the installation cost just to keep your control system running. This is the money you're spending to update things, keep it up to date, do all that. It makes sense if you think about it in terms of cars, like the number of cars on the road. You don't go buy a new car every year, but you probably take it in for service, for oil change, rotation and stuff. So it makes sense that the cost over time is higher than the purchase cost. But, you know, it's still a lot of money, and there's a lot of vendor specific stuff going on in this. So any change we make is going to involve trade-offs and have costs associated with it. So you got stuff that you've bought. All of you guys have. You've got control cabinets. You've got control hardware. That's your controllers, your FBMs, your interfaces, your drives, your valves, all this stuff. This is stuff that's existing in your plant, right? So all of that stuff is an example of sunk cost. And that's why it's going to be hard for us to get to the new stuff. Just like when we're looking at the displays, we've spent all this money on the displays you've got already. And so even if we've got a better control HMI, and if we redid all of our displays from scratch, it probably would be a lot better. You know, we've got to go in there and do that, and it costs a lot of money. We've already spent a lot of money. And so these are things that are hard to get to. You know, sunk cost money you've already spent, you can't get it back. Fixed costs this is like if equipment can be resold or returned, it's not a sunk cost. It's just a fixed cost. But really, you know, PCO's got a guy in here, and like, you know, anybody try to sell their equipment back recently, you're going to find out that you're not going to get whatever you paid for it when you're selling it on the used market. So what are the benefits, right? This is back to the thing you read. I'm not going to read it again, But he says a substantial part of that spending can be avoided through a standardized automation layer. And that's what the open process group is trying to do. They're trying to come out and say, we want a standardized automation layer. I want to be able to go to Walmart and buy a controller, and I want to be able to go to Target and buy the same controller or a different brand of controller that works with it. That's what we're trying to do. Okay? Now, there's another cost. Far beyond the cost savings, standardization would enable you guys, the process engineers, to focus on production improvements rather than rewriting legacy code. How many times have we gone and done this? Rewriting legacy code. A lot of our work comes from retrofits, but in 26 years of doing integration work, I've never had one of our process control guys come to me and say, I'd like to spend the next 4 months working on swapping that old controller for one that does exactly the same thing. Me. I said that. They don't. I mean, we make a lot of money doing that, but we would much rather be doing controls work, putting in a new system, making something new run. You know, Galloway, you're interesting. Tronox, swapping out a CP for an old CP, not so much. Same thing, right? We're not getting anything out of it. It's just make it work like it used to work. You never notice a good retrofit, only ones that go poorly. That's also me. Another thing is, I didn't put it up there, if you quote yourself in a talk, you think you're better than you are. I didn't put that, but I read that somewhere. Let's go through here real quick. I got to get up to my where I am. I was going to just throw these on the floor, but I'm not sure that's a good idea. The next thing is a different thing from Harry, and it says the interdependence of hardware and software and the resulting proprietary methodologies, and be thinking about this because we're locked into these, and the software tools has led to the maladies that manufacturing end users struggle with today in industrial automation. Most notably, this involves the inability to port or migrate existing software from one vendor to another. Further, difficulties involve the scale-up of systems and the inability, inflexibility, high cost of adopting new technology. Furthermore, existing proprietary software tools require too many specialized skills that are both difficult to acquire and not transferable from one vendor to another, right? So, and that's true. If you come in here and you can write sequence code on a Foxboro system, that's great. You can't write that code. You can learn it. It's somewhat transferable, but you can't go onto a Yokogawa system and write C-ball code. It's not the same. It's similar, but it's not the same. You have to learn new skills. So we've got this technical debt where we went in there and we did all this software development. And the technical debt is when you've done an easy but limited solution instead of a more robust approach that takes additional time. Or you go in there and you do this stuff, it gets harder and harder to change. The more stuff we scab onto it, the more we work on it, the more fixes we put in, the harder it is to swap it out. So we've got a lot of this going right now. So what we want is to have multi-vendor interchangeable hardware. So like I said, we want to be able to go buy this stuff from multiple people at the same, Target, Walmart, we don't care. Multi-vendor interoperable software. If we write the code on a Foxboro system, it would be nice to be able to take that same code and run it on a Yokogawa system. This is an opportunity to do that. We want to have common control languages. If you write it in sequential function chart on one, it doesn't have to be the same language. We're not saying we're going to have a language. You're going to have block languages. You're going to have ladder languages. You're going to have function block languages, structured text. You're going to have these things, sequential function chart. But if you move it from one to another, it should work the same way. You shouldn't have to say, if I write a program on one computer and port it to another one, if it's in the same language, you ought to just be able to recompile it and keep going. We want to have built-in security considerations. We want to have standardized administration tools. These are the things that the open process group is trying to get to. So that's their vision, to have multi-vendor interchangeable hardware and multi-vendor interoperable software and common languages and standard connection interfaces and built-in security and standardized tools. So where are we? That's the question. Where are we today and where are we going to? Currently, certifying hardware, they are currently doing this, by the way, certifying hardware from multiple vendors to act as distributed compute nodes, which he handed around earlier today. I didn't even prep for that. Thank you. And we passed one through the group. This is the open process group's idea of the controller of the future. Schneider is there. Thank you, Schneider. You are there. And that's a thing that they had out earlier today. So you've seen that. Okay. The vendors who are in, Schneider and Yokogawa are definitely in. And then you got like Rockwell and ABBs. You see, I kind of made them a little smaller because they're not really as in. They're kind of in. They're in a little, but they're not really in. Okay, but they're at least paying lip service to it. But what's conspicuous is who's out. Honeywell and Emerson are not interested in playing this game. So that's going to be interesting going forward, I think. I think that says a lot about where they're headed. They want multi-vendor interoperable software. Okay. All right. This is great. You have IEC 61131. Who here knows what IEC 61131 is? Raise your hand if you know what that is. Two? Two. Good. You know. I know you know. It's three. I'll give you that. All right. And then we have Code Assist is that's the runtime engine and a lot of stuff. That's basically the PLC type event, not event driven, but the, runs in a sequence code type thing. And then we got 61499. That's the one that we've got. And that's the universal automation, which Schneider had the runtime engine for, and they put that out. Okay. So this is where this is a good thing, by the way, in that both of these models can be used to, like, I believe he showed this. He had a universal automation, and then it said it could run a block that had the 61131 code in it as a separate block. So this is where we're trying to get to. These things are work in amongst themselves. All right. And you have multiple vendors that are in here doing this.
Hey, David.
Yes.
You talked about the vendors. May you also comment about other company end users that are participating in it, other suppliers?
Well, yeah. As far
it's not just a vendor.
Oh, no, absolutely not. We'll get to that. I'll get to the people that are driving this. It's not being driven by the vendors. Vendors, as far as I can tell, don't really want this. I think Schneider's doing an excellent job of being in this space and being responsive to it. But if I were selling, widgets, and I got a widget and you're locked into my ecosystem, if I'm Apple, right, I don't really want Android to have all the Apple apps on it, right? I want mine to be different. And that's what they want. This is opening it up for everybody. So a vendor, I think, is not as prone to do this unless they feel like they can get a lot out of it from, universal automation. I think this is a piece of the puzzle. I think this is not the whole puzzle and doesn't solve all the problems, but I see this as something that's a positive step coming from Schneider. Okay. Universalautomation.org is independent, not-for-profit. How they managed to do that, I'm not sure, but they are managing the runtime execution engine, and that's the one that Schneider produced, spun off, and has got out there in that. And I do see that as something that you're going to see running in the DCNs. It's the execution engine for this, right? So common control languages, function block, ladder, SSC, structured text. Although the IDEs, and this is, I think, again, this is me talking to you about where we're going to see the differentiation. I think this is where you're going to see it. I think if you have a better IDE, a better interface to build the blocks, better development environment, this is where you're going to see company differentiate itself from the other companies, right? If they're all running the same control engine and they all got the same blocks, then it's ease of use. How easy can I make this for someone to come in here and develop on my product? So a standard connection interface. And this goes back to you, Roger. Remember how much we all like OPC with DCOM? It's terrible. It is terrible. It's bad at the best of times. Well, OPC UA, the unified architecture, it's not OPCDA. It's not built off the same thing. I mean, I realize they have the same name, but OPC was OLE for process control, and OPCUA, it doesn't even stand for the same thing. It's the same foundation and the same stuff, but it's a whole different animal. And this is what they're using to do this. It would have been hard to be worse than OPCDA. Built-in security, it's in there. They've considered security from the start. We've got end-to-end encryption on packets. It's hard to come in and intercept this stuff. This in the new model is already there. All right, standardized administration tools. They've got these Redfish IT admin tools. You were talking about the being able to, what is it in, yeah. So the orchestration and the fact that we can move controllers around inside the software, it's there. So it looks like between OPAF and universal automation piece of this, we kind of got something to go forward, maybe. This is the Exxon staging floor, and I got this from Ryan Metzer. He sent it to me yesterday, but it was something they were showing at ARC. But this is an open process automation system that ExxonMobil is putting in. And they're doing the FAT in March, so that's next month. And they're planning to start this up in September. And I believe they have a little over 2,500 IO points in this. I would call it they're calling it the OPA Lighthouse project because they're going to demonstrate how the open process stuff works as part of it. Now, and ExxonMobil's got their little logo there on it. And they told me it was okay for me to present this at the Foxboro Users Group because I checked in with them on this. So they're putting their name out there. And there are other, Andy I lost him, but there are other users that are out there doing this too. And I know that Georgia Pacific has got people on these committees. I know that, Chevron does, a lot of the big names in this. Eastman Chemical was there. So there's a lot of people doing this. So it looks like we have kind of a path forward, okay, as far as what's open and everything. So that's great, except for then we got now MQTT shows up. And that's the message queuing telemetry transport used for Internet of Things applications. Okay, and so it's kind of a competing, I don't know, it may be complementary, but it's a lightweight messaging protocol for use in cases where clients need small code footprint and connected to unreliable networks or networks with limited bandwidth resources. And it's not a full-featured communication protocol. It'd be like using UDP to build a common namespace object manager for a DCS, which would be crazy. But they did it 30 years ago, and it's been working ever since. So it's kind of the same idea. So Sparkplug is the name where they stick the stuff on top of MQTT. And then what you wind up with there is they make a unified namespace under Sparkplug with these brokers, and it comes out, and then they can build it from there. So, and then that comes into your HMI and your SCADA and things like that. And this is a new way of looking at taking your PLCs and you hook them up to this server, and then you just name a tag, and then it becomes available inside that namespace. So MQTT looks like this. You take your different pieces, your PLCs, RTUs, send it into the broker. It's an event-driven thing. Request it, goes out to your SCADAs, data, and all that stuff. Same kind of thing. So what does it all mean to us? Well, it means the ideas are sound. These are good ideas. People want this. This is I mean, I think that they are, barking up the right tree, not the wrong tree in this instance. The OPAF openness as a standard of standards, which is what it is, gives us some confidence that this stuff's not going to get changed quickly underneath us. So if you go in there and you build on this, I think you're going to find that it's sustainable and lasts for a long time. You're not going to have products where you get abandoned. The companies involved are committed to the idea. The Exxon Mobils of this world, they've been at this for years now, and they have said that they are going to continue on until they get what they want. I've talked to those guys. They're not stopping. They've put a lot of money behind this. They are going to continue to put money behind this until it works, and I believe they mean it. But a lot of these technologies that we have are looking to be integrated into a workable solution. And that's where we got to take the universal automation piece of it and make that fit into this. And we're going to see a lot of stuff where we have gateways back to the Foxboro side of this. You're not going to come in and rip out your Foxboro DCS and put in an OPAF system. That's not where we're headed. It's not going to happen. I don't see that happening anytime in the future. What you're going to see, I think, and this is me speculating. This is not stuff I know, but I think you're going to see kind of the gateways and the OPC-UA gateways, and you're going to have your existing Foxboro system with this gateway sitting there, and then you're going to have your OPAF stuff over on the other side, and they're going to talk OPC-UA to each other, and you're going to slowly migrate over to this new platform. And I think that's where things, to me, that looks like where we're headed. And I think this is going to happen. It's just a matter of how long it takes for it to happen. Now, I don't think it's going to happen next year. I don't think it's going to happen the year after that. But I do think that if you start building OPC-UA infrastructure, I think it's going to last. I think that that's a place where you can start saying, I think this is not going to go away in the next 5 or 10 years. And I think that the other people are building onto that. And in fact, on the spark plug stuff, a lot of those spark plug brokers have an OPC-UA wrapper that they have to go to other systems. So so that seems to be the technology that's winning out. So that's all I have on the open part of this, but I hope that was helpful as far as where we're at and what we're doing, and kind of gives you an idea of where we're headed, because I think that's where we're headed. And now, oh, that's good. Yeah, go ahead.
You mentioned all these good things about, this open architecture.
Mm-hmm.
I haven't heard any mention of any anticipated yet undiscovered gremlins that may arise. Like, for instance, 25, 30 years ago, off-the-shelf PCs were going to replace the proprietary systems, and they're going to be great. Here we are 25 years later living with all the headaches that arose from the cybersecurity patching and the rebooting, and it's got a lot of pain that comes along with the off-the-shelf systems. So
yeah.
Is there anything like that is being anticipated with these open architecture systems?
I think, yeah. Well, the thing that's different about this is they took, I'll say this, it's a good question, and it's good for a lot of reasons, not just like, it's a good question, that's a good question. You say that every time somebody asks a question, but that's a good question. If you look at it, the guys that are writing these standards, okay, I went to Houston, and well, maybe the same case today, so I got to be careful what I say here. But I went to Houston and they're involved in this, and there is no doubt that I was the least intelligent person in that room. Okay, I was like going, wow, these guys are really smart, and these are guys that know controls. This is not a guy that just walked in off the street and goes, hey, I got a Microsoft PC, let me sell it to you. These are guys that have been doing control. These are the guys that are running the divisions for the control guys for Exxon and Shell And they didn't just, I mean, they're not academics. These are guys, a lot of these guys have come up, you know, on their tools, so to speak, and know what they're talking about. So the things that I think they see the problems that are already there, security. They are very aware of security and the, you know, dealing with security and knowing that a packet came from where we think it came from and handling that. Okay. They're pushing a lot of that stuff off though, like the HMI stuff. They don't really have it as a part of this because they go, well, we've got the OPCUA, you know, this is going to be our transport mechanism. So you just go buy ignition or Wonderware or whatever, and that's not part of the control system to their way of thinking, right? Whereas the Foxboro system, we say, oh, it's going to run on a AW today with Foxtrot today, I'll say, and that has got to be on a Microsoft machine, and that's got to be patched. And they go, I don't care if you run it on a Linux box, and you know, or if you run it on a Windows box, or you run it on this. That security, we've made the DCS secure, the control system, and then the other part of that you're going to be responsible for. They are thinking of the thing. I mean, security's baked in, you know, today. Speed. They definitely have looked at the speed of this. Can it scale? How big can they go? These are guys that are running refineries. They're thinking about those questions today. They're not thinking about them, oh, wow, if we had, you know, it works great up until we get 12 DCNs and we can't handle 50. They're going, well, at 400, we know we can handle it. You know, things like that. Things that you start going, well, that's huge. You know, well, we know we can handle this. So I think they're thinking of most of that, but I mean, you know, the unknown unknowns, I don't know, but it's, you know, but they are definitely not going to be guys that just went in and said, oh, we'll go buy a network switch and put it in, and this will be your network switch. They are thinking of this in terms of a DCS control system. Yeah, go ahead.
It's just my voice, I guess.
Oh yeah, there you go.
No, one of the things that, because that's a really important question, because actually what we've done is, you know, the committee has pros and cons, right? I think one of the pros to actually doing this by committee is that everybody's bringing their experience to the table. So when we do these plug fests, we call them, right? When we bring technology in and tie it into these systems, everybody's bringing their own experience of how it failed last time to that test. Okay, so it's not just me as the guy responsible for Foxboro bringing my experience, or the you know, ABB guys or the Siemens guys bring in their experience, and every end user saying, well, it failed like this last time. Let's test it. Let's break it. That test bed, well, that was actually the field trial that you showed, but the test bed that they had before, they actually had multiple vendors' hardware, multiple vendor systems. Yokogawa was managing that facility. Right. They were using Schneider software. Everybody in what's behind the other side of that wall there, where that test bed was represented, and every vendor had a vested interest in it succeeding, and every end user has an interest in it succeeding, meaning that they probed that thing as many ways as they possibly could to try to break it. Okay, and so if you think you've experienced in your operations every way that you can break a Foxboro system, I guarantee you haven't. Right? These people are all bringing that experience, and not only are they bringing how they can break a Foxboro system, but how they can break a Honeywell system, how they can break an Emerson system, and they're testing and probing the system to that level of diligence to make sure that it meets their performance expectations. And so, yes, we're going to start small because we should always start small, but to make sure that it meets their expectations in the field, it met the expectations in the test beds, and that's kind of where we are now. But we're evolving beyond that, and Exxon is very confident in this. This is a field trial that they're doing, but I can promise you right now, you know, and Ryan is responsible for this. Ryan Smeltzer from Exxon is how do we start to now scale this and deploy this across the entire fleet? Because as I mentioned, they have a significant installed base of obsolete systems that they're either going to have to rip and replace or replace with something that's a little more future-proof like this. So, but that really was that good question. Thank you.
Yeah. Sure, go ahead. Mm-hmm.
Honeywell, they stayed with their own protocol. Everybody else,
mm-hmm.
beginning of
say their own protocol, they're gonna get left in the dinosaur age.
That way, no.
Yeah.
That way, Honeywell has now gone to the C300s and adapted the part.
Yeah.
Now they're abandoning the old smart Honeywell smart transmitter stuff.
Yeah.
That's where this is going.
Yeah. You ever have Foxcom in your plant?
I'm not that old. I don't know.
Yeah. Well, the guys that had Foxcom transmitter, right? Foxboro made and Foxcom was, and I can say this, arguably better than Hart for a lot of reasons. Okay. And they said, oh, we'll let anybody that wants to, they would license Foxcom, except for nobody wanted to license Foxcom, right? Well, I don't want to be beholden to Foxboro if I got my own instruments and stuff. I want to, do this. So, Hart, I think Hart's like isn't tied to a specific vendor. I think it's just a protocol that went out there like that. Right. Yeah. Right. And so they did it, but not like, in the way back days when Modicon had Modbus, right? Modbus is a standard in the loosest sense of any standard ever in the whole world, right? It's Modbus. Oh, well, everything talks Modbus. Yeah, everything talks Modbus until you try to make something talk Modbus. It's like, it's just like that's how it works. But you can, kind of beat it into submission and you get it to work. But and I get that, but that's the way it is. But now these guys, to your question, yeah, I think. Look, if you don't think that this open automation thing is aimed at a vendor, it is. Okay? It's got a big red H on it and it's sitting over there. And ExxonMobil is like not going to put up with it. Now, the other people playing along, that's a different animal. But they're getting other companies to go in because there is value in this to us. And I don't mean us, EOS. I'm putting on my 25-year ago hat when I was something else. But us as users, the people that are out there buying this, there is value to not being locked in and having these guys compete. And if you're making Schneider compete on building you a better IDE and a better control environment, good for you. And they should compete on that. And they're probably going to win. I hope, maybe not, but at least they're going to get out there and have to provide that product. Okay? And they can compete at that. They can win. They can make money in this. This isn't a zero-sum game. Somebody is going to sell you a control configurator for this system. Okay? And you can go buy a different guy. If you don't like the one you've got, go buy brand X and load your code into it, and it still will load, and use their configurator. And you're going to spend money on that, and that's fine. But when you got to go replace your hardware, you're going to be able to go today. These guys are selling it cheap. It's an AS Rock controller, or it's a Yokogawa controller, or whatever. And you get to decide what you got. And it should be interoperable and tested. So I see this as a win for the users in the long run. And the other part of this, because there's a whole lot to this, it does make everybody, if this gets traction, everybody starts speaking the same language. We all, knowing a control system today means a control system. In the future, knowing a control system means all the control systems. And that's where we're trying to get to. Yes?
Just a question, Michael, I guess. Where do you see things, specialized things like Triconics safety sealed rated systems, or Woodward high speed, turbine controllers? Where would they fit in the structure?
I think for the time being, they are a gateway thing and they're kind of left alone. That's the way I see it for now. Yeah. Mm-hmm.
We believe that in order
either 2 or 3 systems, we don't have to be able to do more than any one vendor can provide, right? You know, Dave said it right. I mean, I think if we look at where software is going and the ability for you guys to say to anybody who's using technology to produce their final product or service or whatever, we have to be able to do that unconstrained by the capability of any particular vendor that you select. Right? That's my thing. You have to be able to use our tools to achieve your outcome. And if our tools can do the job, then you should be free to go get tools somewhere else. That's a big vision. That's very probably not in full alignment with everything that the rest of my organization believes. That's what Foxboro is doing. That's what DCS is doing.
I guess the thrust of that question though is it's a DCN is going to be held to try to safety certify. That's what is it? Well, it can be anything. Well, that's part of the certified. So I don't see how you're going to get away safety search from not having fixed hardware.
So I think what you're going to see is that evolution of itself, right?
Well, Galen, what's going to happen in the nuclear industry is they're going to run AP20s in 2024, and they're going to do that because they're going to go, we can't replace these. And that is crazy. Yeah, it was.
So we talked a lot about writing. Does this work? It does. So we've talked a lot about swapping environment. Is there any requirement in the standard that if I use Automation Expert, I develop all my code base there, and Schneider goes to a new product I don't like or whatever, that all my code that I've developed, I can then go make modifications in another software, or maybe a smaller scale would be my OEM developed a Packer using Siemens, whatever they have that's equivalent. Am I going to be able to bring that into something like Automation Expert and make changes?
So it depends on how they package it. Where I was talking about that composite automation type. So you can actually run that. It is an envelope, if you will, of an application. It's got triggers for events, and then it's got standard inputs and outputs. So if you, for example, if you want to be a software manufacturer, you can actually create your own proprietary code to say run a piece of equipment, whether it's a skid piece of equipment or not, and lock that composite automation type to where all you see is the inputs and the outputs and the event triggers. Okay, so you can manage and maintain your intellectual property however you want. So if you buy something like that and you want to bring it into Automation Expert, and this is something else that's actually really cool, is you can bring these cats in from different people. They don't all have to be made by Schneider Electric. There's another company, 4D right now, and a 6149. Cats on them, cats on ours, create a common application. That's the beauty of the 61499 standard, is you don't have to choose. You're not, just by selecting to start with Automation Expert, you're not bound to it forever. And going back to that interchangeability, you can create an application that actually at ARC, there was a small startup company that was building composite automation types for different applications. So they had created an advanced process control CAT that they had locked down. You could buy, getting to that app store type of model directly from them, and drop into an EAE application and start using tomorrow, or a 4DAC application. 4DAC applications that you create, that's another development
Yeah,
environment,
right.
will run on the universal automation runtime. So it's there now. It's just it's at an infancy in terms of people getting comfortable and it getting real runtime, but the technology is available today to do things like that. So long answer to your question, but you don't have to be bound just if you create everything in Automation Expert.
Yeah, I think that that's an accurate statement based on what I know. And I mean, the way they're doing that, they've got these modules and they're compliant and they're going to expose the, here's how you run it. And then you can move that from model to model because it's going to run in the same runtime engine.
Absolutely. One of the things that we are doing, though, back to OPAF, is that all of the blocks that you see, because I think Dave, you mentioned this earlier, but the blocks that are being contributed to OPAF by the different organizations, including Schneider Electric, so your analog input blocks, your PID blocks, those will all be open source. So those, if you want to pull those from the OPAF library and drag them into your application, they're open source in the sense you can get in and change the way the PID block works if you want, right? So there's that level of open. But then there's, I want to buy this specific app with this performance guarantee from a vendor. I can also drag and bring those into my library as well. So
yeah,
it is kind of the Wild West right now.
It is. There's a lot going on here. And, this is, and I'm not sure how it's going to shake out, but I do think these are the things we need to be looking at as we go forward because it's going to change. The world is going to change dramatically, I think, somewhere in the next 10 years.
In the next 2, but
Yeah,
I'll stick with your 10.
Yeah, I think 10. And I think in 10 years, if I don't think it looks at all like it looks today. And that's different because, you take a guy from 1993 and you bring him into 2023 and it's like, well, this looks pretty much the same. And I think you're going to take a guy from 2023 and drop him into 2033 and he's going to go, whoa, this is completely different from what I had 10 years ago. And I think that's where we're at right now. We're at kind of an inflection point on a lot of this stuff.
I'm trying to get my head wrapped around this VCN. So is the VCN, is that basically just Docker host machine?
Yeah. Oh man, don't. This is good. We don't have this kind of time.
Yes and no. Over a beer, only later, because I can't drink right now. But we'll talk.
Yeah. There's a whole bunch of things, and you have different ways you can set them, and
yeah, there's different models of DCN in the
yeah.
standard. There's different types of DCNs that are called out in the standard. So.
Yeah. So, all right. Anything else about the open part of this conversation? Because then this will be great. I'm going to hit my time perfectly, I think. So then we'll be right back on track. I got 11 minutes. Yeah, I won't even need that now. Okay, the FDC 280/FDSI update. Thad pretty much covered it this morning, so I'm going to hit that again. On the FDC 280, the Modbus driver has been available for years, is still available. It's a standard offering. The Triconix TSAA driver has been available as a standard offering. It's been there for a while. The OPC UA driver, I am told, is now available as a standard offering. Is that correct? Okay. The Ethernet IP driver for your Allen Bradley stuff will be available in 2024. And the Profinet driver, he says, is coming as a custom offering. That means you get to pay extra for the privilege of running it early in summer of 2024. So that's the FDC 280. Yeah, it's true. Driver update. Is there any other drivers coming we don't know about?
I mentioned the Modbus server. That was an earlier one.
Yeah, it's available now as a standard though, is it not?
Yeah.
So that kind of falls under my mod. I should have said Modbus drivers for both, but yeah.
Driver, is there anything regarding explicit or implicit messaging that you may want to comment on that?
That's actually a three-phase approach, a three released phase approach. The implicit messaging, I think, is the third phase. So yeah, it's coming this year. Not there yet.
Okay. And then on the Ethernet FDSI, They're going to go off sale after February of 2025, and they may extend that some.
I promised an extension on that. I don't know how long that's going to be, but I promised an extension beyond that.
March 1st, 2025.
It could be
Yeah.
February. It could be February 31st. I don't know.
There is no February 31st. We get a 29th this year, though.
Yeah,
So, yeah, never, never. And then as far as the Ethernet FDSI update, as far as form factor and being able to put it out in the field where it was, some sort of replacement is in the works, but we do not have a time frame on that. So if you're building a new communication gateway, obviously if you do an FDC 280, you're good because you're not going to go stick it in a base plate somewhere remote because you can't. So that's a good thing. If you already have FDSIs at a remote base plate and you need to replace them because that's how your architecture is set up, they still have them available and they're going to be serviced for a long time. And then at some point they think maybe they will make another one to replace it. Is that right?
And you remember the QR code this morning where I put up the
I did.
and
you're out of the office.
Yeah, I think over half the room scanned that QR code.
Yeah.
So
yeah.
there's a lot of feedback, and we welcome the feedback into forming this new what we call the Gen 2 FDSI.
Right. So, okay, so that's that. So I am giving back 8 minutes of time, I think. And somebody who is next on the agenda. When Galen asked a question, at no point did I say that's a great question. I just let him ask questions. Come on, you know it's true. The question was, he says, looking at the DCNs and the path forward and things like that, would there be, and well, I'm going to paraphrase a lot of this because I'm going to get what I want in here. Why don't you make an FDC 280 that can host IO? I think, is that kind of, yeah.
To make the controller accept OPC commands to get the code from EcoStruxure,
Right.
then it has to have a gateway in it.
Yeah. So the DCNs do. You're correct. And as far as your thought process, as far as going forward, yes, you're correct. Now, hold that thought. Now let's
next year.
take this to, we're going to have an FDC 280 with IO next year. Is that what you're telling me?
We're going to have an EAE based controller that can communicate multiple protocols and do control.
Which is not exactly the question, but I mean, so are we going to have something that will sit on the mesh that we can?
I didn't hear mesh in his question.
Yeah, well, he didn't. That's no.
FDC.
No. I
Yeah.
changed
So what he's
question.
describing is the head unit. If you guys remember from earlier today, the head unit is something that can talk PIO bus or can talk on the mesh to the one side and then talk EAE on the other side.
Right.
And that's a head unit, and that's currently under development this year. It won't be out this year, but it's currently under development.
But what about, okay, again, I think we're splitting this in a different way, or at least I'm going to ask a different question. Why don't we make an FDC 280 that can have a PIO bus that can host, FBMs? That's the question.
that was the original intent of the FTC 280, and we ran into so many roadblocks, doing technical roadblocks, that we could not do it. So therefore, the FCP 280 is our controller.
Okay.
This would have replaced our FCP 280.
I mean, yeah.
So now we've got the 280 where we can do an enhanced online upgrade. We've invested into upgrading the components. We can build it indefinitely right now. So in combination with an FDSI Gen 2, that's how we're addressing the issue. Originally, that was the idea, was to say, okay, FDC 280 is going to be our controller. It's going to be our device integrator. It's going to host.
It's going to do it all. Yeah, that was the thought, but it wasn't able to do that. Okay. So
we can talk about it over a taco or something.
Okay. So basically, I hijacked your question, changed it a little, and got mine in there. But that was the idea.
It was like the telephone game, right? It's just like somebody asked it all.
Yes. What's the plan for the future of the FDC 280?
It's No, I mean, FDC 280 is a very powerful device. It doesn't, like I said this morning, it's not a panacea. It didn't do everything. It did too much. I liken it to like trying to kill a fly with a sledgehammer. You just bust up everything and you miss the fly, right? But it's a very powerful device. It has its place in the system as have the ability to do 8,000 blocks, multiple protocols, all at the same time from a single FDC 280. That's where its place is.
But when you say that the FCP 280, you can continue for the foreseeable future.
FDC, same.
The FDC in the same boat.
Same, yeah.
It's the same. Okay. Same. All right. That's what I think you were trying to ask. Yeah.
Well, you got the question right this time.
That time. Well, I didn't hijack that one.
All right.
Okay. David, I think you're up.
All right, so control HMI I'm going to talk about a little bit here. Obviously, Cadre, you came out. You talked a lot about HMI is kind of in a philosophy, if you will, how to how to make better HMIs. This my presentation is going to be focused a lot more on specifics, screenshots, and more of a day-to-day what you need to know if you're going to install the software. What are just some things you need to know going in that are going to be different when you go to make changes. So basically what you need to know at a high level, it's not going to be training, but it will be hopefully just some differences you need to be aware of to look into. So the first that, you know, some people will probably know some of these terms, but we throw a lot of them around. So I just want to make sure we're all using the same words. So my little chart here, I don't know how well you guys can read that in the back, but there's 3 columns here. The first one I call legacy software, basically ICC, Foxview, Foxdraw. The second column is control software. That's what Foxboro has decided to brand all these products that are equivalent to what we had before. And the third one, many of you won't care about that, but if you have seen Wonderware outside of Foxboro, that's kind of the Aviva Wonderware terms. So, you know, legacy Foxboro, we have ICC. Everybody here knows ICC. That's not a question. It's where you make your controls configuration. And this is about control HMI, so I won't spend too much time, but control editor, if you hear that, that is what Foxboro wants you to call it. We call it Evo a lot, but it is the control editor. And that's done within, from a Aviva terminology, the program you run is called the Orchestra IDE. So I really just want to make sure that when I say these words that I think we see a lot of sales presentations, no offense to the sales guys, but you know, this is an application you run to do configuration changes. And for what it's worth, that's also Orchestra IDE is where the HMI application lives now. Kadre talked about it being kind of centralized now rather than file-based. So just a couple more terms, Foxview and Foxdraw is where you view and edit your displays today. The terms that I'm going to use, Control HMI as a whole is the HMI platform, but that's 2 separate applications, just like Foxview, Foxdraw. There's Window Viewer and Window Maker. And then as an asterisk that I'll get to later, I just told you do a lot of your graphics in the IDE in Orchestra. So for this crowd, we've all got a Foxboro background. Very few people go the other way, which we do in our office. We have a lot of people that know InTouch, know Orchestra, and we have to teach them about Foxboro. So just briefly, system platform InTouch, it's 2014, 2023 on the newest software, is its own product, which you may or may not know, right? There are a lot of Orchestra systems, system platform systems talking to whatever PLC, multiple types of PLCs. And I just want to point out here that I don't think it's pushed very much by the Foxboro salesman, but you can actually, I forget the exact product name. It's like device integration software or something like that. You can actually talk directly to, from your HMI, any of those PLCs and about 30 more different kinds of PLCs. So there's really an opportunity there to cut down on how much we're using our FDSIs. I know most of the time, about 80% of that is just reading it into Foxboro just to show it on a screen. So yeah, and just in general, what Foxboro did, obviously Schneider bought Foxboro or Invensys. I don't know how that went down. There's a lot of features in system platform that Foxboro went and added more features so that it worked with Foxboro. And just a few that that you can do in system platform that did make sense for Foxboro to develop. So when you're looking at this, a lot of the documentation, you'll see references to Wonderware documentation instead of the B0750 whatever. In a lot of ways, those are still two separate organizations. All right, key differences. I'll spend less time on this slide than I meant to, just because Kadre covered it pretty well, I think. Control HMI is a lot more modern feature, more modern environment to work in. In particular, the scripting, there's basically no scripting in FoxView, Foxstraw, very limited. And you can do more than you should if you want to in Control HMI. And I'll talk a lot about the easier management of symbols. I've got a whole, that's about half my presentation. The cons, I don't know how well you can tell. So I mentioned complexity. You can do more, which means you can do too much. That's all I'll say on that. I kind of grayed out this slower to deploy small changes. In the latest release, as Kadre mentioned, you can deploy a screen rather than restart the whole application. And then there are a few features that you can kind of tell that Wonderware was its own product, and then they added Foxboro. Sort of how you manage string tags is one I'll talk about in more detail. Did anybody know here that there's a limit on the number of trends you can add to a FoxView screen? Has anybody ever hit that? Performance-wise in particular, but there's actually a hard limit of like 16, I think. Go ahead.
Question, just for clarification. When you say scripting, are you talking about like display manager command scripting, or are you talking like corn shell, Bernie type shell scripting? Just so I understand what scripting you're talking about.
Yep. So I'm talking about display manager scripting in FoxView Foxstraw. And then it's similar to .NET scripting in Control HMI. So historians, just in general, Kadre talked a lot about how trends are a great way to improve the, more high performance graphics. And that's really where you start to run into limitations with FoxView Foxstraw, is anytime you're trying to do some of these shape type displays, if you're wanting the operator to look at the shape of a trend, you end up with a lot of trends. Foxstraw, but at least to the best of my knowledge, there's no other way around. You can't have an AIM historian with Control HMI. You can migrate the data though. So this matters a little bit less with the latest release, but in older releases, InTouch was around before Orchestra came around, before Wonderware was bought by Invensys. So all I'll say here is that the InTouch graphics you might run into, I know Julio, you brought this up the other day, it's completely different in how you configure those graphics compared to industrial graphics or orchestra graphics. And this was originally a mistake, but I thought it was important, so I left it in there twice. The InTouch application is older and less intuitive, so just develop all your graphics in the Orchestra IDE. So I'll be pretty brief on some of the graphic editor improvements. Hopefully these screenshots help put a finer edge on some of the things that you've heard from in abstract before. So in general, these are just the things that I think are good for day-to-day stuff. So in Foxdraw, we all know if you create a group and then you want to edit anything in that group, you copy it, you paste it, you ungroup it, you make your changes, you regroup it, and you copy the scripting from the old object and then delete it. Well, in Control HMI, it's Control R. You can edit a group without ungrouping it. Properties. So in most applications, right, you've got your screen where you move stuff around, and there's this box over the right where you can individually change each of the properties. That's not really there in FoxView, Foxdraw. You just kind of drag it around and make it work. So like X and Y position, width, height, you can enter numbers for those rather than just trying to line manually. A couple new elements, radio button group, you can add an actual checkbox, a list box. I know on the newest software, you can import some SVGs and make scalable graphics. This is a small but noticeable difference. If you're in Foxdraw, if you want to change strings, you hit Control T and you work through the list and change your strings. I think it's a little bit more intuitive in Control HMI. You select whatever you want and you bring up this dialog box to substitute strings. You can search and replace in that list or individually change them. And then references like tag names work basically the same way. Some of the animations, for the most part, they're going to be equivalent to what every other HMI package has. Two things I wanted to call out is that there's a tooltip animation, which is great for reducing noise on the screen to, only show a number if you hover over it or something like that. And the number one improvement there is that you can actually do expressions. I don't know how well it shows up on this TV, but we've all built a calc block to make your display show, this number times that number, or in this case, I'm showing visibility if the number is equal to 1. So in Control HMI, you can actually add numbers together, basically any expression that you can build. Just as an example, something we did recently, we were using calc block steps to hold strings. So they were all comments, and in FoxView Foxdraw, pretty much what you have to do is just tell your operator ignore that semicolon at the beginning of the line. In Control HMI, you can do like a mid string and just cut off the first character. Sky's the limit there, and again, that's one of those things that's helpful, or you can do it too much and create problems for yourself. So trigger tags. Foxdraw, if you're showing a string expression, you have your string tag, call it string 1 on an independent block. And then you have to have a trigger tag that tells it when to update that string. That's really kind of, I don't want to call it a limitation, but that's just the way object manager lists work in Foxboro. What was that? Annoyance, sure. I mean, there's good things. There's a reason it's written that way, right? But for us building an HMI screen, it's definitely an annoyance. That works a little bit differently in Control HMI, and this is one of those areas that I think you kind of see that Wonderware was its own product, and then they had to make it work for Foxboro. So rather than having a field for the string tag and a field for the trigger tag, what Control HMI does is this # FT extension as an example. F stands for frequency of how much to update. T stands for trigger. There's a whole document on other options, but FT is what you would use for a trigger tag on a string. So if you can read this middle block here, you can be as explicit as you want on that trigger tag. Basically, all three of those are the same syntax. If you just do FT, it's going to assume it's an independent block, and you want to look at the message number parameter on the same block. Or you can give it a different parameter name, or you can just spell out the full compound block and parameter. I linked this manual here that talks about all the different frequency and data access extensions. I don't know if this still applies, if it'd be the same manual for the latest version or not. So the next big thing, the next couple things are all about improving consistency. So in FoxView, Foxdraw, what we have is, oh, come on, somebody tell me, conventions. So we've all seen probably conventions. They're kind of a pain in Foxdraw to manage. The analog to that, I'll say, in Control HMI is element styles. So if you can read what I've done on the left there, those are element styles for different strings. So I pick a title element style, and it sets the font size, the font color, and I think that's it. There's also an element style for heading, label, tag name, and you can create your own element styles, and there's a whole list on the right there of the different element styles. And it's not just for text. Kadri kind of alluded to the idea that, you know, your pump running element style, that's active element style. You can change that and it'll update everywhere you're using that element style. It's a, you know, it's that dialog box on the right there. You pick it, you change the color, and it applies everywhere, as long as you're consistent about using it. So with this, the way it was before January of this year, or whenever 8 came out, you basically had to deploy the application. You still do have to deploy your application, and that's where he was talking about before you had to restart the application, but now you just reload the screen like you would any other change. Yeah, in general, I'll talk about embedded symbols, but there's a huge advantage to this kind of application-based architecture versus file-based. So connectors and connection points, if you can see it, kind of looks funky on the TV screen, but what I'm showing there is basically you can have shapes connected with like Visio-like connectors. So you add a connection point to these squares, you draw a connector between them, and then if you drag it around, it'll try to keep those connected. And just like Visio, that's fine as long as it's pretty straightforward. If you're doing a bunch of crazy stuff to go around the whole display, sometimes it's not as helpful, but it at least keeps it from like not lining up at the bins. And scripting is a whole thing from Wonderware, but I have this one slide to talk about. It's a lot more full featured. So just as an example of something I threw together here, this is a schedule. It's reading from a SQL database, pulling that in, and it'll resize those rectangles based on the schedule, start and end times. You know, I developed that, and you know, it's all done pretty much in scripting, which, you know, I don't even know where you would start on Foxdraw to try to do something like that. And there's also no Foxboro blocks involved in that. It's all memory variables, if you will. I've got one slide for situational awareness library. That's a whole thing that comes with Control HMI. I will point out that if you right click in the graphic toolbox, there's help files for that go into a ton of detail of how to configure each one of those. But the big thing is it's provided by Aviva / Schneider. A lot of the symbols are built for Foxboro blocks. And it just, especially for that level 1 dashboard type screen, gives you a better starting point. All right, embedded symbols. This is basically symbols or faceplates that you do in FoxDraw, but way better. So the first thing is, like I said, they're analogous to a faceplate or a symbol that you develop in FoxDraw. You develop one symbol and reuse it a bunch. Custom properties are similar to like the P codes I think somebody mentioned earlier, or if you have aliases, that type of thing. It's basically how you pass values into your symbol from where you use it. So there's a lot of quality of life differences that make embedded symbols easier to work with. The first is if you have an embedded symbol, you can right click on it and convert it to a group. So at that point, it's no longer linked to any kind of template. It's just as if you drew it for the first time. The next is how easy it is to actually edit those symbols. So if you're on a screen and you want to edit the symbol, you just right click, edit embedded symbol, make your changes. I think in this, I just add some text below like a PID block. You save your changes, and at that point, your changes are made everywhere. If you have something open, which is what I'm showing here, you have to tell it to go grab the latest changes if you have it open for editing. If you make a change to a symbol, you just deploy the application and it's updated everywhere it's used. Symbol Wizard. This is something you benefit from if you're using libraries from Schneider. Cadre, he mentioned how you can pick a valve and tell it whether you want it up, left, down, or right. Those are done using the Symbol Wizard. So as you could pick, you basically get like a symbol wizard-like option to go through. This is a meter, kind of an analog display. You can pick whether it's pressure, flow, pick the orientation, whether or not to show engineering units, that kind of stuff. And as opposed to any kind of like visibility, that happens in the design time. It's not taking up resources to hide and show while it's running in the runtime. And then I just had a couple missed opportunities. I was going to take this slide out, but I thought it was worth leaving up there because both of these things that I listed are, Schneider has mentioned both of them today for different reasons. I mentioned the idea that if you've done system platform orchestra work before, you typically build an object with attributes, and then you build the graphic for that object. And I had listed out that as a missed opportunity to be able to say, for a strategy, you should be able to build a graphic for that strategy. And then Michael came in and talked about where we're going with automation expert and doing that exact same thing, kind of linking your controls with your graphic. The second one I had were Aviva OMI not being an option with Control Software 8. Let me just take a second to point out that Control Software 7.5 or 6 was the latest before that, is System Platform 2014. And 8 all of a sudden is 2023. So that's basically you know, we said the acquisition was 2014, right? So, 2 months ago, you had almost 10-year-old software from Wonderware. And the latest is now the, the latest version from Schneider is the same from Foxboro is the latest from Aviva, essentially. So there's a lot of improvements there. 9 years, yeah. So, again, Wonderware is its own product. Aviva is its own company, and they were developing for 9 years to improve their product. So, Control Software 8, I'm excited to see all the improvements there. I had OMI as being a missed opportunity, but just getting to the latest software is really covering almost all the things I would complain about not having OMI. And then again, OMI is the plan for Automation Expert. All right, and then any questions? How do I do on time? 3 minutes.
When I do go in a control room on Friday, I don't do, but and they're gonna say, can you fix this? It's been a problem with 2 weeks. How long is it gonna take me to open the editor to troubleshoot a problem, say a certain start in this talk-to section? And, I've got to break it down. I've got to get in and see what bit it is, and I may have to go into the configurator and
I'll say that Fox v. Fox for all experience.
that, like in the Fox's draw, you're still gonna have to open ICC, whatever.
Yeah. So I know on 7.5 there was the option. So you have a similar, you find the block in Fox Select, you double click, it's called block select, it's the same. They definitely concerted effort to make the window viewer interface kind of not the same, but close enough that you aren't lost. So if you want to you open block select, you find a block. It opens block detail displays. Some subset of the information. Up over here. Probably had block. It is nice. Similar on the computer. Straight to log. Blanket statement. The anything on the controller that you don't like, there's 3 good reasons that that change is like that. Right. We don't like not having our full screen block detail displays that show us everything. But the advantage to that is that you can have 4 different blocks. But, you know, as far as you
room for about 20 minutes where the users can talk freely amongst themselves, come back if we have any questions, concerns, comments, things like that. And then that user session will last longer than that 20 minutes. We'll go on with it for until we wind down. And then after that, we'll go over to Taco Mac. We can bring the questions down to Taco Mac. We could do that. Well, you guys, we'll put you out for a little bit and you can come back in if you want. How's that? You don't have to come back in, but we will get any questions we've got. We'll give you a cookie. Yeah, I'll put one in. Yeah. Okay. Up next, Darren Moffett with Schneider on the Electrodynamic controller.
Hello? Is that better? Okay. So I guess two things. I'm the last one until your session, but everybody's got their sugar and caffeine right from the break, so we're good. Good. All right. For those, see some familiar faces. For those that I don't know, my name is Darren Moffett. I've been with Schneider for, I guess, a little over 31 years now, based out of Pennsylvania. Worked with a group of technical sales consultants focused on the Foxboro DCS, a couple of which you've already heard from today. So happy to be here to introduce the Electrodynamic controller to you, at least probably to some of you. How many people were at the Innovation Days in Massachusetts last May? I would see so. So if you were there, you probably got introduced, or at least had the opportunity to get introduced to the Electrodynamic controller. If you weren't, right, now's the time. I'll explain to you what it is, how we got there, with the benefits of it, and those sorts of things. I don't have it actually physically running, but we got this one and another one sitting out in the table. So stop by and take a look at it as the week unfolds. It's kind of the evolution of about 5 or 6 years worth of effort, right? As we'll talk a little bit about that as we go through. And if we look at what we're going to talk about for the next half an hour or so, just go to a quick introduction to what we call integrated power and process. And we'll talk a little bit about, what that means, how do we get there, what are the benefits of it, what are the problems we're trying to solve through the integration of power and process. We'll talk about this electrodynamic controller, how it fits into that solution. We'll get a little bit more technical details of the controller, show how it works with the Foxboro DCS, show some architectures, explain some of the behavior of the device itself, and then we'll talk a little bit about how you can get started if there's interest in taking advantage of that. All right. So let's jump in with just a quick introduction to integrated power and process. All right. Hopefully you can see. I was sitting in the back before. It's not always easy to see all the details on these slides, but all right, still there. But so hopefully, I'm sure you get a copy of these things so you can see a little bit later. Oh, I'm going too fast. So when we look at a typical plant, right, you got the process side of things. You got your tanks, your pumps, your motors, your valves, the materials, the people that are making the products, and then you've got the electrical side of the energy management systems that are used to power and protect that equipment. Unless it's a completely manual process, right? You're going to have a little bit of both, and you're going to have some integration between the two, obviously, to be able to power and electrify the process equipment. Well, traditionally, right, there's not been a lot of integration between the two, and what integration there has been is typically been through some sort of hardwiring, right? Hardwire some signals into your control system, be able to control some equipment, that sort of thing. What we're finding now is that kind of that division is getting narrow. Right? We're starting to see a lot more interest in that integration, even though some of the struggles around that are that it's typically in a plant controlled by two different groups, right? You've got your process engineers, the people who work on the process side. You've got your electrical engineers, or the people working with the switch gear, transformers, substations, those sorts of things. And there, it can be different vendors, all that goes into the different aspects of the equipment. So there hasn't been a ton of integration, but what we're finding is that's now starting to change, and it's really about getting that information together and to be able to make better decisions, right? To be able to have an operations personnel be able to see what's going on the electrical or energy management system, to be able to make some better decisions based upon what the loads are on the electrical system for a given day, be able to make some better decisions should an upset condition occur, how to take action in those sorts of situations. So kind of the goal of this integration is really to bring those two worlds together, right? We're starting to see that happen more and more. Driving the integration is a lot of some of the mega trends out there that I'm sure everybody deals with on a day-to-day basis, whether it be the younger the expectations of the younger generation, entering the workforce now, and their views on sustainability and green, and be able to drive the initiative and support the initiatives that are driving towards those goals. Return on investment, right? We're always looking to shorten schedules, reduce costs, reduce downtime, increase yields, right? All of those activities are taking place within manufacturing facilities today, and digital transformation is kind of the technique or the application that is really driving, accelerating those trends. So the drive for data, right? What data can you get out of your plant? How can you take advantage of that data to make better and more informed decisions? And the integration of power and process is another avenue to bring more data to that decision-making process. So being able to have all that information together, available digitally, to be able to make some good decisions. So that's really kind of what driving the integration. Our role from Schneider, kind of like the little Schneider plug here, right? We want to be your digital partner for sustainability and efficiency. We're doing this across multiple industries today, focused on manufacturing efficiencies. And this is just yet another way through the use of the introduction of this controller and the integration of power and process to make that happen. I'm sure many of you, if not everybody, has seen the EcoStruxure architecture from Schneider. My only reason to bring this up is just kind of show you where the integration of power and process fits into this. If you have the connected products, the edge control, the apps and analytics layers of the EcoStruxure architecture for integration of power process, right? We're bringing together the DCS, we're bringing together the power automation system, and the electrodynamic controller is kind of the glue, if you will, the facilitator to make that happen. That's where it stands within the edge control layer of the EcoStruxure. Looking across the life cycle of a plant, right, from design, engineering, design, all the way through to optimization, there's a lot of different ways in which this integration can impact the plant. The portfolios of Schneider, Aviva, and all of our partners help to drive this, help to drive reduction in capital expenditures and operational expenditures. And again, within the integration of power process, we kind of live in this little area where we're increasing the amount of data available to make decisions within the facility and drive some of the benefits. That's kind of just a little brief introduction to power and process, why we're here, why we're talking about it. If we look at now what is this electrodynamic controller, what's it do? Again, kind of if we take a step back and look at traditionally how that integration's been done, it's either been done from some sort of hardwiring of the automation system to your energy management system, or through some sort of gateway. Right? We've been doing this for years within the Foxboro system. I've heard a lot of discussion around the FDC controller, FDSIs, through Modbus connectivities and other protocols. We've been doing a lot of this integration already, right? And again, through some gateway devices that we've had within Schneider for several years. What the current state, what we're driving towards, is the elimination of those gateways, right? The elimination of those extra devices, those extra firewalls, things like that have to be part of that architecture, and have a single device that can integrate those two worlds and bring that data together and make that available for operations personnel. All right, so that's where the electrodynamic controller that's where it's placed, that's what it's there for, is to be the bridge between those two systems. Hopefully you can see some of this detail from the back, but we look a little bit more at that controller itself. It's really kind of the first controller that Schneider's provided. One of the first on the market that provides direct integration to the electrical subsystems, right? You'll see a reference to IEC 61850 on there, which is a substation automation standard. We'll talk a little bit about that in a few slides. But the kind of the purpose behind this device is to provide that 61850 connectivity into the substations, into the medium voltage intelligent electrical devices that are out in that facility, right? In addition to that, it's a Foxboro controller, right? So it acts and behaves like a Foxboro controller. We'll talk about that in more detail as well, but it sits on the Foxboro DCS control network. It runs blocks. right? It has peer-to-peer communication with other Foxboro controllers with your FCP 280s and your FDC 280s. It has been qualified for SSA level 1 security. So it's gone through the same qualifications that the FDC and the FCP 280 have gone through. So it's part of your overall cybersecurity architecture. It's engineered through the same tools that you would engineer your Foxboro controllers. Last April, it was released in Simplex, Simplex architecture, and just this last December, so a couple months ago, we released high availability. So now the ability to have 2 of these controllers working together to be able to provide, again, another level of assurance around a single point of failure. And it also continues to support hardwired I/O. So in many cases, many brownfield applications out there that have existing non-intelligent devices, right? You still want to be able to bring that information into the overall architecture, and you're able to do so with the I/O cards that are supported by this device. That's the device itself. That's what we're talking about today. I've got some examples here. One of the primary goals of the device is to simplify, as we talked about already, simplify the architecture. So it's what we kind of coin as a dual citizen, if you will. Right? It sits in the Foxboro world and also in the energy management world. So it go back there, right? So it sits with the real simple picture here, but sits with so it actually has connections. We'll see them in a second. It has connections to your Foxboro control network, to your mesh switches. It also has connectivity into your electrical systems. It communicates to low voltage devices through Modbus, right? Your motor starters, your drives, that type of equipment, and it'll communicate to the medium voltage equipment, the intelligent electrical devices via the 61850 standard protocols, communication standard. We kind of do a little bit of a deeper dive into the functionality of the controller, and a little different representation of that same architecture. Right? Again, as a dual citizen, it sits on both networks. It's a peer-to-peer, not only to the other controllers in the Foxboro world, but it can also communicate peer-to-peer to other controllers in the electrical world. So, right? So it actually is able to pass data back and forth between the two. Oh, jumping ahead again. We've done qualification thus far. You can see some of the numbers up there of 214, a single controller or a single pair of controllers in a high availability setup can talk to up to 214 low voltage devices, your motor starters and so forth, or it can talk up to 59 medium voltage intelligent electrical devices via the 61850 protocols. Or any combination thereof, and it's scalable, so you can continue to add additional controllers as necessary, depending on the systems you're trying to talk to and the number of pieces of equipment you're trying to communicate with. Right? Within the controller itself, as we'll see, is where you define your logic, right? Your motor start-stop logic, your auto transfer switch logic, all the logic required to be able to bring that information in from the electrical devices and make that available to your operations screens and on your HMI screens for operations personnel. It also then has the ability to take some of that low voltage information that's coming in through Modbus and be able to republish that to the electrical management system, so you can do some more take advantage of some advanced applications such as fast load shedding or generation management, things like that that are done on the process automation system. Or power automation. So we'll talk a little bit about how that's where we qualify that, but those are the currently documented standards for device support. Mentioned 61850 a couple times. I'm not sure if that's new to a lot of folks in the room here, but that is a kind of substation automation and interoperability standard. Originated back in 1995. First published, I think, in around 2002, 2003. So it's the standard for substation automation, right? So it's the way in which those medium voltage devices communicate. Consists of different domains, including the standard series of standards has a data model, describes a number of different communication protocols that are supported. There's an engineering configuration language that's described within those standards. similar to it's kind of very similar to our EcoStruxure model. It talks about different levels of the electrical system from the process level up into the supervisory level, including your HMI. So it's a very popular standard when you're working with substation automation and power automation systems. There's a wealth of information online about the standard, including the standard itself. Hopefully, when you get these slides, right, I have a link here to a very simple, easy explanation of the standard that's done on YouTube. So if you get a chance, take a look at that. It lays out all the different technology stacks and so forth that are supported within the standard. That's a good little primer to get you going. Within the controller itself, we support a number of different protocols, including the 61850 edition 2.1. So that's the official version of the standard that we support, both client and server. We support substation events, the publisher and subscriber, also known as Goose events from the substation, so we can take advantage of that. Obviously, talk Modbus to some of the low voltage devices. And there's some diagnostic utilities as well as some time synchronization utilities built into the controller, so that you're able to have unified time synchronization across all of your equipment. That's the support for the protocols built within. If we look at, I could say it's probably easier to see it up here than it actually is on the device. You have to stop by the table and take a closer look at it. But from the component standpoint, right, what are the pieces and parts that you get and specify and put together? There are different configurations of the system itself. There are different card files. So there are card files that have up to power supply, controller, and up to 10 different I/O cards. You've got a smaller configurations with 5 I/O cards and a controller, and one with just one. This is kind of one of the mini configurations, right, with a controller and several I/O cards that are capable of putting in that building within that system. If you've got, like I said, there are 2 different types of controllers. One has a built-in power supply. One requires an external power supply, as you can see in the biggest rack there on the left, the biggest card file. Again, not gonna be able to see much of the detail on here, but you'll have ports for the high availability communication between the 2 devices. Over on this side, you're gonna have your connections to the Foxboro DCS control network. So you have your fiber cables that go in there, connect into your DCS switches, right onto the switch, right onto the mesh network itself. You've got communication ports here for connectivity to the electrical networks. It's all built into the controllers. Again, some other displays and power capabilities within those controllers as well. All part of that, all documented. There are as we mentioned, hardwired I/O is still available. There's 2 different I/O cards that are supported with this controller. There's a 4-channel analog output module, and then a multi-input, multi-output card as well that can be supported within the configuration. I think I've got an example of the multi-input output card with the devices that we have for display out there on the table. So those are the components that you can put together to build your system. Again, you can have multiple controllers depending on how many devices you're trying to connect with. I know you might have trouble seeing these slides from the back. So what I wanted to kind of look at next was a little bit about the architectures, how this device fits into the overall process and power networks. Just to kind of point out some of the pictures here for those of you that may have trouble seeing it. So in this is a simplex architecture where we have 2 different controllers. One is shown connected directly to, well, both are shown connected to the Foxboro control network. So you've got your fiber connections coming out and going into your standard mesh switches. Again, you have connectivity to any other existing Foxboro DCS components that might exist in your network. Any hardwired I/O through the I/O modules that are supported. And then you, again, being that dual citizen, you have the communication coming out of those controllers down into your electrical ring networks. So this is showing one controller dedicated to low voltage devices via Modbus, and a second controller connected into the medium voltage devices via 61850. doesn't have to be separate. One controller can connect to both. It's just shown in a more simplistic architecture here with one controller dedicated to each area. Just to reiterate some comments from before, right? If the low voltage devices can be republished up into the power automation system to be able to take advantage of that data within that system for some of those advanced applications. If we look at the next architecture, shows the same thing, very similar, but with high availability. Right? So in this case, it's showing 2 controllers for the low voltage and 2 controllers for the medium voltage devices. It's also showing a little bit more development of the fast load shedding and generation management systems on the power automation system. We take advantage from if you guys are familiar with the FCP 270, right? The splitter combiner capabilities that brought those controllers together on the mesh. Take advantage of that same technology to bring the high availability controllers into the Foxboro control network. Right? So standard stuff that's been around for a long time. We take advantage of that and be able to leverage that to get the high availability controllers into the Foxboro network. All communicating. You can see different networks here, including one to the master timekeeper. Talked about that SNTP, the time protocol, or a little bit earlier. All that part allows you to put a singular time synchronization to all your events and alarms coming from both the power system as well as the process system. So now you can have a unified sequence of events type of reporting and data displays to be able to see events taking place on both sides, right? All in one view, all in one report. This is a little more of a blown up picture of that same high availability architecture. Won't spend much time. Nothing really different about that than the previous one, just a little bit easier maybe to see in the back. So the other part of this is, so we talked about it being a Foxboro controller, right? So it sits on the mesh, as we talked about. It supports the Foxboro blocks, and now it doesn't support all the blocks. It supports about a dozen blocks. You can see the list of the blocks on the screen there. You know, analog inputs, analog outputs, some alarm blocks, calc blocks to be able to build the logic inside that controller. It's configured through Control Editor, right? So it uses the Foxboro DCS Control Editor to be able to configure that. It's sort of this is a screen capture taken from Control Editor, which shows that Electrodynamic controller as a device inside of Control Software 8.0 with the release of Control Software 8.0. Again, talks peer-to-peer with other Foxboro DCS controllers, but we wanted to make sure you're aware that it's not all the blocks, but it is the portion that's required to do the power logic. Yeah. Correct. That is correct. Yeah. Good question. I figured that was coming, but yeah. The other thing that was done as part of the DCS integration is there was a development of what's called the states view, a control HMI application. So it requires control HMI, not for FoxView. So at least have one display within your system. You can coexist Foxboro and FoxView and control HMI. So you'd have to have at least one control HMI station, but it is a built-in display that allows you to see the health and status of all of your electrical devices from the Foxboro console. So you can drill down into the device, you can see what's going on in the device, get information about it, help with making some decisions should you have some issues on the power side, and you'll be able to see all of that from within your Control HMI display. So it's a pretty powerful built-in display that comes with Control Software 8 and is available for wherever the Electrodynamic controller is used. Any questions on any of that integration? Sure.
Basically going to replace the CP, and it's going to be like a real-time controller.
So it's not going to replace the CP. It's another controller, right? So it's another controller, but it doesn't support the typical Foxboro I/O modules like the FBMs, right? So it supports its own I/O modules to be able to connect into the electrical equipment as opposed to process equipment.
So a regular CP has a phase of like second or half a second.
Right.
It's this
It's a good question. I don't know the specifics of that, but it's designed to be very quick. Some of those protocols we talked about like Goose and those other 61850 protocols are designed to be very high-speed protocols to be able to capture the events that are taking place in the power side. I can get you specifics on the actual. Yeah. Yeah.
To coordinate breaker trips.
Yep.
Coordinate breaker trips with something that happened in your automation at the same time. Yeah, it needs to be quick.
Yeah, and it is. I just unfortunately don't have that data off the top of my head, but we've got the documentation here. I can share that with you. The nice thing about this device is it's not a new device, right? This is not something that we just went out and built this brand new device. It's been part of the Schneider Electric SCADA offering for a number of years. What we've done is we've enhanced it. We've added some additional firmware, some additional software to be able to let it do what it already did best, which is talk in the SCADA world, in the power world, to be able to support those types of applications, but now also live in the Foxboro world and be able to communicate with Foxboro controllers. Mentioned that, what is it, 214 and 59, the number of devices. Those numbers come from our pretty extensive test lab that's in India. And so this just threw up some pictures here just to give you a sense of the testing that's being done on this. There's, I think, over 500 different devices that are set up, both Schneider and other third-party devices that are set up in India in the test lab to be able to run this thing through its paces, so that you have the confidence when you get it that you'll be able to support the devices, number of devices that we've talked about. And again, you could very scalable. So if you have more in a larger systems, just go out and drop more in. Typically what we see is that you have one of these controllers per substation or per substation is the best way to think about it, or per area, right? And then you just bring that back to the Foxboro network through fiber cables back to switches. So pretty extensive performance labs and so forth, putting the testing together for that. Last thing is just around how to get started. So if you have interest, this is just an opportunity to share the new device with you, get you kind of thinking about it a little bit, how it might fit into your plants. Documentation is available. I can get it to you if you want, or if you have access to our global client support website, you can go and download the new PSS and some user documentation that explains all about this in a lot more gory detail than I've been able to share with you in the last 20, 25 minutes. We've got customers that are already using it, that are putting it into some of their test facilities and offline systems to be able to kind of kick the tires, run it through its paces, and plan and put their plans together to be able to integrate this into their facilities, again, to simplify their architectures and be able to get rid of the gateways and some of the other complicated things that complicate the architectures when they're trying to integrate that data and get that data all shared within their operation screens. So we've got customers that are using it already. And invite you to again do the same thing, kind of read up on it. If you have interest, reach out to myself or reach out to any of the Foxboro sales or technical folks that you deal with on a day-to-day basis. We can come take a look at your plant, walk it down, look at single line diagrams, look at different substations, kind of see how things are laid out, make some architecture recommendations for you, how it would potentially be integrated in with your Foxboro DCS. Look at the DCS itself, see how to architect the best solution for your facility. But again, look forward to opportunities to work with you on this controller. We're really excited about it, and again, if there's any opportunities to move forward, let me know, or talk to your local Schneider folks. Questions? It does. Yep. Oh, it's a good question. I might have to actually, Steve, are you familiar with that? Yeah. Probably the same ones, yeah. I'll double check that for you. Though. Good question. Good question. Yeah. Next project. Good question. I'll get. Yeah. Hopefully I can answer it. Not familiar with that, so I'm not sure.
Sounds like SEL competition to me.
Okay.
I was gonna say we did the same thing. Not the same thing.
Yeah.
I had a question. We did something very similar. We had smart buckets.
Right.
Tied into network switches. We built a switch gear that we just slowed it down. And breakers that came. All that came into an architecture.
Okay.
Translated protocols.
Okay.
What's the advantage? I guess the advantage of this is you have Foxboro DCS.
Right. It's a single device. Right. Yeah. 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 You absolutely could. Yeah. Yeah. Yeah.
And what we did, we brought all our data in, monitoring data. We hardwired it.
Better. Thanks. I like it when you guys answer you guys other questions. This is good. Makes my life easier. Yeah, fantastic. I probably don't know the answers anyway, but that's good. Yeah. 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 No, these are based upon real data from customers. However, it might not necessarily be from that controller, right? It's going to be from the different applications of power and process application. So for example, in a big capex savings, might potentially will be from upfront engineering. So if you had a greenfield facility and you could do all the design for your power system and your process system together upfront, understanding everything before you did anything, you could help size things a little bit more accurately and appropriately, so you can reduce the amount of the time it takes to engineer and design a system as well as the cost to develop it. So these are real data, but it might be across different strategies, if you will, different approaches to the. Absolutely, yeah. It is. I just don't know the specific details of which customers and things like that, but certainly find out industries and get a little bit more detail behind that. Good question. We good? Thank you for your time.